Hello there and welcome to Life Beyond Seen, a place where curiosity slows down a little, questions stretch their legs, and science takes the scenic route towards sleep. Tonight we're drifting somewhere unusual, somewhere vast and dark and strangely fascinating. Somewhere that covers most of our planet, yet remains one of the least understood places we've ever tried to explore, the deep ocean. Now, for many people, the ocean is peaceful. A gentle horizon, waves rolling onto the shore, the distant sound of gulls, maybe a quiet stretch of beach where the water glimmers under the sun. But that peaceful image tends to change the moment you start thinking about what lies beneath the surface. Because the ocean is not just water. It is depth. It is darkness. It is space without walls. And sometimes that space makes people uneasy. There is even a word for it. Thalassophobia, a fear of deep water, of the vast ocean, of the unknown that stretches below the surface where sunlight fades and shapes dissolve into shadow. It's the feeling you might get when floating in open water and realizing there is nothing beneath you for thousands of meters, just empty blue descending into black. Now, before we go any further, I'm curious about something. Where in the world are you listening from tonight? Are you near the ocean right now, or somewhere far inland where the nearest sea might be hundreds of kilometers away? And what time is it in your little corner of the world at this moment? It's an interesting thought, isn't it? A video about the deep ocean, listened to by people scattered across continents and time zones. Some of you might be winding down after a long day, others might be half asleep already. Perhaps a few night owls are simply curious about the strange mysteries that hide beneath the waves. If you find this journey relaxing or interesting, or simply a pleasant way to drift into sleep, I would be very grateful if you gave the video a like and maybe subscribed. It helps this quiet corner of calm reach other curious minds who might enjoy a slow wander through science before bedtime. Now then, settle in. Let your thoughts slow down a little, because tonight we're going somewhere very deep. Imagine standing at the edge of the ocean just after sunset. The horizon is fading into a soft grey-blue line, and the water stretches outward in every direction. The surface looks calm enough. Maybe a few waves, maybe the faint movement of the tide. But if you were to step into that water and begin swimming outward, something interesting would happen to your sense of space. At first, you would still see the shore behind you. The lights of houses or street lamps might glow faintly in the distance. The water beneath you would look pale and translucent. You might even see fish darting below your feet. But the farther you swim, the deeper the water becomes, and the colour begins to change. The pale green fades into darker blue. The shapes below you blur into something less distinct. Eventually the bottom disappears entirely. Now you are floating over depth. Not a shallow bay, not a sandy seabed just a few meters down, but something much larger, hundreds of meters, perhaps thousands. The ocean floor is still there, of course, but it has dropped far below your line of sight. All you can see beneath you now is blue that slowly fades toward darkness. Many people describe a strange feeling when they experience this for the first time. It's not exactly panic, not always. Sometimes it's more like a quiet tension in the back of the mind, a subtle awareness that the environment around you is enormous, far larger than anything we normally interact with. Humans are quite comfortable with solid ground. We understand landscapes that have edges and surfaces, forests, mountains, valleys, plains. Even deserts make sense to our brains because we can see the land stretching away in clear shapes. The ocean is different. It has depth instead of terrain, and depth is something the human mind struggles to visualize. If you stand on top of a mountain and look down into a valley, your brain can estimate the distance. Trees, rocks, and slopes give your perception something to measure. But when you float above deep water, there are no reference points, just colour fading into darkness. For some people, that sensation alone is enough to trigger discomfort. Because the mind quietly asks a question. What is down there? This question is older than modern science. Humans have been asking it for thousands of years, Sailors crossing open oceans often described a strange feeling when travelling far from land. Even when the sea was calm, there was always the sense that something enormous existed beneath the surface. Part of this reaction comes from the way human perception evolved. For most of our species' history, we lived on land. Our ancestors walked through grasslands, forests, and river valleys. Water was something we drank, fished in, or crossed carefully. But it was rarely our primary environment. The ocean, especially the deep ocean, was never a place humans evolved to navigate naturally. Our bodies are not designed for it. We cannot breathe underwater. We cannot see clearly in deep water without equipment. Our hearing becomes distorted, our movement slows, and our sense of orientation becomes unreliable. In other words, when humans enter the ocean, we are stepping into a world where nearly every instinct we rely on becomes less useful. The brain notices this immediately. It begins scanning for potential threats. This doesn't mean sharks necessarily, although popular movies have certainly helped reinforce that association. The fear often appears long before any creature enters the picture. Instead, it begins with scale. The ocean covers roughly 70% of Earth's surface. It holds about 97% of the planet's water. In terms of sheer volume, it represents one of the largest continuous environments on Earth, and much of it remains unexplored. Scientists estimate that more than 80% of the ocean has not been directly observed or mapped in detail. To put that into perspective, humanity has sent spacecraft far beyond our solar system. We have mapped the surface of Mars, photographed distant galaxies, and tracked objects millions of kilometres away. Meanwhile, vast regions of our own oceans remain largely mysterious, and the deeper you go, the stranger things become. Sunlight, for example, does not travel very far through seawater. Even in clear conditions, light begins to fade significantly after about 100 metres. By 200 metres, the brightness drops dramatically. Beyond that point, darkness begins to dominate. At around 1,000 metres deep, sunlight disappears completely. Below that depth lies a world where the sun has never shone. A region so dark that many of its inhabitants produce their own light through biological processes known as bioluminescence. But before we reach those depths, it's worth considering why the idea of deep water alone can trigger such strong reactions in people. The human brain is remarkably good at pattern recognition. It constantly tries to interpret shapes, movements, and sounds to determine whether an environment is safe. On land, this system works well because most environments are visually stable. Trees remain trees, rocks remain rocks. Even animals usually appear in recognisable forms. Underwater, especially in deep water, visual information becomes limited. Light scatters, colours shift toward blue, distances become difficult to judge. Something large moving beneath the surface might appear as nothing more than a shadow, and shadows allow the imagination to fill in the blanks. Psychologists sometimes refer to this as ambiguity amplification. When sensory information becomes incomplete, the brain compensates by imagining possibilities. In safe environments, this might lead to curiosity. In uncertain environments, it can lead to fear. Floating above deep water creates exactly that kind of uncertainty. You cannot see the bottom. You cannot easily estimate distance. You cannot move as quickly or confidently as you would on land. So the mind quietly increases its alertness. Even people who enjoy swimming sometimes report feeling uneasy when they realise how deep the water below them truly is. Scuba divers describe a similar moment when descending along steep underwater drop-offs. At first they follow the slope of a reef or underwater wall. Then suddenly the seabed falls away into open darkness, a vertical drop that might extend thousands of metres. Divers often pause at that point, hovering beside the cliff of coral or rock, peering out into the deep blue. Because looking into the open space produces a curious mixture of emotions. Fascination, certainly. But also something else. A quiet awareness that you're looking into an environment where humans rarely belong, and that awareness is often the beginning of thalassophobia. Not necessarily a panic-inducing terror, but a persistent sense of unease around large, deep bodies of water. Interestingly, this fear does not always come from negative experiences. Many people who report thalassophobia have never had a traumatic encounter with the ocean. Instead, the fear appears when imagining certain situations. Floating alone in open water, looking down into endless depth, seeing something large moving slowly beneath the surface, or simply thinking about the scale of the ocean itself. Because scale matters. The average depth of Earth's oceans is about 3,700 meters. That's deeper than most mountains at all, and certain locations go far beyond even that. There is a place in the Pacific Ocean called the Mariana Trench, where the seafloor drops to nearly 11,000 meters below the surface. At that depth, the pressure becomes so intense that it would crush most surface objects instantly. Submarines designed to reach the bottom must be built with extremely thick pressure-resistant hulls. Yet even there, life exists. Creatures adapted to darkness, cold and crushing pressure move slowly through that hidden world. Fish with translucent skin, squid with enormous eyes, strange organisms that glow softly in the black water. For someone with thalassophobia, simply imagining these environments can produce a strong emotional reaction. But fear and curiosity often travel together, because the same unknown that unsettles us also invites exploration. Humans have always been drawn toward mysteries, even when those mysteries make us slightly uncomfortable. Which is why scientists, engineers, and explorers continue sending submersibles deeper and deeper into the ocean. Each descent reveals new landscapes, underwater mountains taller than Everest, volcanic vents where superheated water pours from the seafloor, entire ecosystems thriving in places once thought completely lifeless. And yet, despite all this exploration, the deep ocean remains one of the most mysterious environments on our planet. A place where darkness stretches for kilometers, where pressure reshapes biology, and where creatures evolve forms unlike anything seen on land. For some people, that thought produces excitement. For others, it produces a shiver. And somewhere between those two reactions lies the quiet, fascinating psychology of thalassophobia. Because the fear of deep water is not just about the ocean itself. It's about the way human minds respond to vastness, uncertainty, and environments that exist far beyond everyday experience. And as we continue this slow descent into the science, history, and psychology of the deep ocean, it becomes clear that our fear of it is not simply irrational. In many ways, it's a very human response to a world that is still, even today, mostly hidden beneath the waves. The first time a person looks down into truly deep water, something subtle often happens in the mind. It might occur while leaning over the side of a boat, floating above a coral reef that suddenly drops away into darkness, or standing on a cliff where the ocean below shifts from bright turquoise to a deep, almost ink-like blue. At first, the view can be beautiful. Calm waves, sunlight dancing across the surface. But then the eye follows the water downward, and that is usually the moment when curiosity turns into something slightly different. Because the ocean does not reveal its depth easily. Unlike a valley or canyon on land, deep water does not show clear edges or slopes. The seabed may plunge steeply only a short distance from the shore, disappearing beneath layers of blue that become darker and darker as they descend. When a person looks into that fading colour, the brain tries to measure distance, but there are no clear markers to guide it. So the mind hesitates. It asks a quiet question that has followed humans for thousands of years. How deep does that go? This reaction is more common than people sometimes realise. Even individuals who enjoy swimming, diving or sailing occasionally describe a brief moment of unease when they encounter water whose depth they cannot see. It does not necessarily turn into panic, Often it is just a pause, a small shift in awareness, like the mind stepping carefully into unfamiliar territory. Part of this response begins with how human perception works. Our brains are extremely good at understanding environments filled with solid objects. Trees, rocks, buildings, and mountains provide reference points that help us judge distance and size. When you walk through a forest, your brain quickly calculates how far away a tree is, how tall it might be, and how long it would take to reach it. These calculations happen automatically, but deep water removes most of those reference points. Once the ocean floor drops beyond visible range, the only thing left beneath the surface is colour and light gradually fading into darkness. Without familiar shapes to anchor perception, the brain loses its ability to estimate scale. A person floating above a depth of 10 metres may see a faint outline of the seabed. At 20 metres, that outline becomes vague. At 50 metres, it may disappear completely. Yet the ocean may continue downward for thousands of metres. The mind cannot easily imagine that kind of depth, so it responds with uncertainty. Uncertainty is something the human brain tends to treat cautiously. From an evolutionary perspective, our ancestors survived by detecting potential threats quickly. When entering unfamiliar environments, the brain increases its level of alertness. Sounds become more noticeable. Movements draw attention. Unknown spaces invite careful observation. Deep water triggers exactly that type of alert system, not because it's inherently dangerous in every situation, but because it is unfamiliar territory where our usual senses become less reliable. Vision, for example, changes dramatically underwater. Light behaves differently when passing through water compared to air. As sunlight penetrates the ocean, different wavelengths fade at different rates. Red light disappears first, followed by orange and yellow. Blue wavelengths travel the farthest, which is why deep water appears blue from the surface. As a result, objects underwater quickly lose their natural colour. A bright red object placed 10 metres below the surface may already appear dark grey or black. Shadows stretch differently, shapes blur at the edges, and distance becomes difficult to judge. This altered visual environment can confuse the brain's normal interpretation of space. Something small but close may appear large and distant. Something large but far away may appear faint and undefined. When a swimmer or diver looks down into deep water, the mind begins searching for patterns. It tries to interpret subtle variations in colour and movement, but often finds very little information. And when information is limited, the imagination becomes active. This is not necessarily a flaw in human thinking. In fact, it is a useful survival mechanism. When the brain cannot clearly identify something in the environment, it prepares for multiple possibilities. In everyday situations, this can be helpful. If you hear a sudden sound in the forest, your brain immediately considers whether it might be an animal, a falling branch, or simply the wind. But in environments like the deep ocean, where visibility is limited and scale is enormous, that same system may generate possibilities that feel unsettling. A shadow beneath the surface might simply be a change in water depth, or it might be something moving. The brain cannot always tell the difference immediately. Many people report experiencing this feeling while swimming in open water far from shore. At first, the surface may seem calm and peaceful, but after a few minutes, the swimmer may notice how little there is to focus on visually. No trees, no buildings, no clear bottom, just water stretching outward and downward. At that moment, the swimmer might glance below their feet and see nothing but blue fading into darkness. For some people, this produces a brief wave of discomfort, not necessarily fear of a specific creature or danger, but a sense of vulnerability. On land, humans rely heavily on the ability to stand, run, or climb. These options provide a feeling of control. In water, especially deep water, movement becomes slower and less predictable. Your body floats instead of standing firmly. Your speed depends on how quickly you can swim. Your vision is limited to the surface unless you dive beneath it. These changes alter the brain's sense of safety. It is not that the ocean is automatically dangerous. but rather that humans are operating outside their most familiar environment. Another important factor involves the concept of scale. The ocean is the largest continuous habitat on Earth. Standing on a beach, the surface may appear flat and manageable, but beneath that calm exterior lies a vertical dimension that is difficult to comprehend. Consider this comparison. The tallest mountain above sea level, Mount Everest, rises about 8,800 meters into the sky. The deepest known point in the ocean, located in the Mariana Trench, descends nearly 11,000 meters below the surface. If Mount Everest were placed inside that trench, its peak would still remain more than 2 kilometers underwater. That is an enormous vertical space, and the vast majority of that space exists in darkness. For humans accustomed to landscapes shaped by sunlight and clear horizons, the idea of such a deep environment can feel almost unreal. The deeper you go in the ocean, the more conditions change. Temperature drops steadily. Pressure increases dramatically. Light fades until it disappears entirely. At a depth of 1,000 meters, the environment becomes what scientists call the midnight zone. Sunlight cannot reach this region at all. The water is completely dark except for occasional flashes of bioluminescence produced by living organisms. These flashes may appear as tiny glowing dots drifting through the water, or brief pulses of blue light from fish and squid. For the creatures that live there, this darkness is normal. For humans, it is difficult to imagine, and sometimes the imagination fills that darkness with unknown possibilities. Interestingly, the fear of deep water does not always appear in people who live far from the ocean. Even individuals who grew up near coastlines sometimes describe similar reactions. Surfers occasionally mention moments when they sit on their boards waiting for waves and suddenly become aware of the depth beneath them. Scuba divers speak about the moment when a reef wall drops away into open blue water, revealing a vertical descent into darkness. Sailors crossing large stretches of open ocean sometimes describe a strange quietness when they realize that thousands of meters of water lie beneath the hull of their boat. These experiences highlight something important about human psychology. Fear often arises not from direct danger, but from uncertainty combined with scale. The ocean contains both in abundance. Even modern technology has not completely removed that sense of mystery. Sonar systems can map the seafloor. Submersibles can descend to extreme depths. Satellite measurements can estimate the shape of underwater mountains and trenches. Yet despite these tools, large portions of the ocean remain only partially explored. Scientists estimate that more than 80% of the seafloor has not been mapped with high precision. Entire ecosystems may exist in regions that humans have never directly observed. This knowledge alone can contribute to the psychological impact of the ocean's depth. When standing near a forest, we generally assume we understand what might live there. Deer, birds, insects, perhaps larger animals depending on the region. But when thinking about the deep ocean, the list of possibilities becomes less certain. Creatures discovered in recent decades include transparent fish, giant squid, glowing jellyfish, and organisms that thrive near volcanic vents, where water temperatures exceed 300 degrees Celsius. Many of these animals appear unusual because they evolved under conditions completely different from those on land. Large eyes designed to detect faint light, flexible bodies adapted to extreme pressure, bioluminescent organs used to communicate or attract prey. While these adaptations make sense biologically, they can look unfamiliar to human observers, and unfamiliar shapes often trigger curiosity mixed with caution. But it is important to remember that most deep-sea creatures are not dangerous to humans. In fact, many of them are fragile and rarely encountered by people at all. The ocean's vastness means that human interactions with deep ocean life are extremely limited compared to interactions with animals on land. Still, the mind does not always rely on statistics when forming emotional reactions. Instead, it responds to images, ideas, and imagination. Looking into deep water presents the mind with a blank canvas where possibilities feel limitless. For some individuals, that blankness feels peaceful. For others, it feels unsettling. And for a significant number of people, it creates the specific sensation known as thalassophobia, a fear not just of water itself, but of deep, open water where the bottom cannot be seen and the unknown stretches far below. What makes this fear especially interesting is that it often appears even when people intellectually understand that they are safe. A person standing on a sturdy boat may still feel uneasy peering into dark water. A diver equipped with advanced gear may still feel a moment of tension when descending toward deeper zones. These reactions are not signs of irrational thinking. They are reflections of how the human brain interprets environments that differ dramatically from the landscapes in which our species evolved. And the ocean, especially the deep ocean, is one of the most dramatically different environments on Earth. It is vast, dark, and filled with life forms that follow rules unfamiliar to our everyday experience. Which means that when humans encounter it, even from the safety of a shoreline or a boat deck, the mind often responds with a mixture of awe and caution, two emotions that have always accompanied exploration, because every time humans look into deep water and ask how far it goes, they are facing one of the oldest mysteries on the planet, a world hidden beneath the surface, stretching downward into darkness, waiting patiently to be understood. When people experience a sudden unease around deep water, it may feel like a purely modern reaction. Perhaps the result of films, dramatic photographs of deep sea creatures, or stories about the ocean's darker mysteries. But the roots of this feeling likely reach much further back in human history, long before submarines, scuba gear, or even written language existed. To understand why the deep ocean can trigger such powerful emotions, it helps to step back and consider how the human brain developed over hundreds of thousands of years. Our species evolved in environments where survival depended on quickly recognizing danger and responding before it was too late. The individuals who noticed threats sooner were more likely to survive, and over many generations those instincts became deeply embedded in human psychology. In other words, the human brain is designed to pay special attention to unfamiliar environments. And from an evolutionary perspective, the deep ocean has always been one of the most unfamiliar environments humans could encounter. For most of our species' existence, humans lived on land in landscapes shaped by grasslands, forests, rivers, and mountains. Early humans hunted animals, gathered plants, built shelters, and navigated terrain where the ground beneath their feet remained visible and predictable. Water, of course, was still important. Rivers provided drinking water and fish. Lakes offered food and transportation routes. Coastal regions often supported large communities because of abundant marine life. But even when early humans lived near water, they usually stayed close to the shoreline. Shallow waters are relatively easy to understand. The bottom remains visible. The waves move predictably. Fish and other animals can often be seen before they approach. Deep water is different. Once the seabed disappears from view, the environment becomes far more difficult for humans to interpret. Our senses are simply not designed for that space. Vision becomes less effective underwater because light scatters and fades. Hearing changes because sound travels differently through water. Movement becomes slower and more physically demanding. Even basic orientation becomes confusing because there is no solid surface beneath your feet. From an evolutionary perspective, this creates an environment filled with uncertainty. And uncertainty has always triggered caution in the human brain. Imagine an early human standing near a coastline tens of thousands of years ago. The waves roll onto the shore just as they do today. Fish move through the shallows. Perhaps small boats made from wood or animal skins allow short trips along the coast. But if that same person looked out toward the open ocean, they would see a vast expanse of water stretching beyond the horizon. No landmarks, no visible bottom, just depth and distance. For early humans, that kind of environment represented both opportunity and risk. The ocean provided food, especially along coastal regions where shellfish, fish, and seaweed were abundant. Many early societies became skilled at harvesting these resources. Archaeological evidence shows that humans were collecting shellfish along shorelines more than 100,000 years ago. But venturing far from land required new skills and tools. Boats had to be built. Navigation techniques had to be learned. Knowledge of tides, currents, and weather patterns became essential. Even then, the ocean remained unpredictable. Storms could appear suddenly, strong currents could carry boats far from shore, and beneath the surface lived creatures that early humans could not easily observe or understand. It is likely that these experiences shaped how the human brain began associating deep water with caution. Over time, natural selection tends to favour individuals who respond carefully to environments where survival becomes more uncertain. Consider a simple example. Two early humans approach the edge of deep water. One feels cautious and decides to stay close to the shore. The other swims far into open water without hesitation. If unexpected currents, cold temperatures, or hidden dangers appear, the cautious individual has a better chance of avoiding trouble. Across many generations, this pattern gradually reinforces a tendency toward caution around unfamiliar environments. This does not mean that humans evolved to fear the ocean specifically. Instead, we evolved to respond carefully to environments where our usual survival strategies become less reliable. The deep ocean happens to be one of those environments. Another important factor involves how humans perceive large open spaces. On land, open areas like plains or deserts can still be understood because the ground remains visible. A person can judge distances, see approaching animals, and move quickly if necessary. Deep water removes many of those advantages. A swimmer floating above deep water cannot easily determine how far the bottom lies below. They cannot see what may be moving beneath them, and they cannot move as quickly or effectively as they could on land. This combination of limited information and reduced mobility naturally increases the brain's level of alertness. Scientists who study fear responses often describe this as environmental uncertainty. When entering environments where sensory information becomes incomplete, the brain shifts into a more cautious state. Heart rate may increase slightly. Attention becomes sharper. The mind begins scanning for potential threats. This response is not unique to the ocean. Similar reactions occur when humans enter dense forests at night, explore unfamiliar caves, or walk through dark spaces where visibility is limited. But the ocean adds an additional element that makes the reaction even stronger. Depth. Depth is something the human brain struggles to imagine accurately. When looking down into clear, shallow water, the brain can measure distance by comparing objects on the seabed. But once the bottom disappears from sight, the mind loses its visual anchors. Without those anchors, the brain cannot easily determine whether the water beneath you is 10 meters deep or 1,000. This uncertainty allows imagination to fill the gap, and imagination often favors caution. There is also evidence that humans respond differently to vertical environments compared to horizontal ones. Standing at the edge of a tall cliff often produces a similar reaction to looking into deep water. The mind becomes aware of the vertical drop, and the body responds with increased alertness. But cliffs at least provide visible edges and surfaces. Deep water hides its vertical dimension almost completely. The drop may be thousands of meters, yet the surface appears calm and flat. This hidden depth creates a psychological contrast that many people find unsettling. Interestingly, similar reactions appear in other animals as well. Many land animals avoid deep water unless they are specifically adapted for swimming. Mammals such as deer, wolves, and primates generally stay close to shorelines when crossing rivers or lakes. They prefer environments where they can still see or reach the bottom. This behavior likely reflects the same basic survival principle. Environments that limit mobility and sensory awareness are treated with caution. Humans, however, possess an additional layer of response shaped by our ability to imagine unseen possibilities. Unlike most animals, humans constantly construct mental pictures of what might exist beyond the limits of direct observation. When looking into deep water, the brain may begin generating questions. How deep is it? What lives down there? How far does the darkness go? These questions can trigger curiosity, but they can also create anxiety when answers remain unknown. Another evolutionary factor involves the way humans respond to predators. Throughout history, many threats to human survival came from animals that approached quietly or remained hidden until the final moment. Large predators such as lions, leopards, crocodiles, and sharks often rely on stealth. The human brain became highly sensitive to situations where something might approach unseen. Deep water naturally fits that pattern. Objects beneath the surface are often difficult to detect until they come closer to the surface. Shadows move slowly through shifting light. Reflections distort shapes. Even harmless movements, like fish passing through deeper water, can appear as larger shapes from above. This uncertainty may activate the same cautious instincts that helped early humans survive encounters with hidden predators on land. Again, this does not mean that deep water is inherently dangerous in most situations, but the brain does not always evaluate environments based purely on logic. It relies on patterns developed over long periods of evolutionary history. If an environment resembles situations where hidden threats were possible, the brain responds with heightened awareness. Over time, this heightened awareness may develop into a persistent emotional reaction for some individuals. That reaction becomes what we recognize today as thalassophobia. It is important to remember that fear itself is not necessarily negative. In many cases, it is simply a signal from the brain encouraging caution. A person who respects the power of the ocean is more likely to take safety precautions when swimming, boating, or diving. They may check weather conditions, stay near life-guarded beaches, or avoid dangerous currents. In this sense, a certain degree of caution around deep water can actually be beneficial. The challenge arises when that caution becomes overwhelming, preventing people from enjoying environments that are otherwise safe. For individuals with strong thalassophobia, even photographs or videos of deep water can trigger discomfort. Looking at satellite images of the ocean, watching underwater footage, or imagining being far from shore may produce feelings of anxiety. But these reactions still originate from the same basic system designed to protect us. The brain encounters an environment where information is limited, scale is enormous, and familiar survival strategies seem less effective, so it responds carefully. Understanding this evolutionary background can sometimes make the fear easier to manage. Instead of viewing the reaction as irrational, it can be seen as the brain doing what it evolved to do, paying attention to unfamiliar spaces where caution once meant survival. At the same time, modern knowledge allows us to approach the ocean with tools and understanding that early humans never possessed. We have maps of coastlines, weather forecasts, navigation systems, diving equipment, and safety protocols developed over centuries of exploration. These tools help transform the ocean from an unknown frontier into a place where humans can safely travel, study, and even enjoy. Yet the ancient instincts remain. Even experienced sailors sometimes pause when looking out over vast stretches of open water. Divers occasionally feel a moment of awe when descending along underwater cliffs, where the seabed drops away into darkness. And swimmers floating above deep water may still glance below their feet and feel that quiet tension as the blue fades into something deeper. These reactions remind us that the human mind carries echoes of its evolutionary past. A past where unfamiliar environments demanded attention, where survival depended on reading subtle signals in the landscape, and where vast unknown spaces were approached with respect. The deep ocean, even today, remains one of those spaces, a place where ancient instincts meet modern curiosity, and where the human brain continues to balance fascination with caution as it looks into the depths below. When people hear the word thalassophobia, they often imagine a very specific kind of fear. Perhaps someone panicking while swimming in deep water, or feeling unable to board a boat because the ocean seems too intimidating. Those situations certainly exist, but the psychological experience of thalassophobia is usually more subtle and complex than that. In many cases, the fear does not appear as a sudden panic response. Instead, it emerges as a quiet discomfort when thinking about or encountering vast bodies of water. A person might feel uneasy while looking at photographs of the open ocean. Others might avoid documentaries showing deep sea footage, or feel a strange tension when viewing images taken from underwater cameras pointing into darkness. What makes this reaction interesting is that it often appears even when the person understands logically that they are safe. Someone watching a video of deep ocean exploration from the comfort of their living room may still feel a slight tightening in their chest, or a sudden urge to look away from the screen. To understand why this happens, psychologists often examine how the human brain processes environments that feel enormous, uncertain, and difficult to understand. One of the key psychological elements behind thalassophobia is the human response to vastness. The human brain evolved to operate within environments that are relatively manageable in size. Forests, plains, hills, and rivers all contain boundaries that can eventually be reached. Even large deserts or mountain ranges still provide visible terrain features that help the mind organize the landscape. The ocean is different. When standing at the shoreline, the water stretches beyond the horizon in every direction. The surface appears almost perfectly flat, offering very few visual clues about distance or depth. Beneath that calm surface lies a vertical dimension that may extend for thousands of meters. This combination of horizontal and vertical vastness can overwhelm the brain's ability to form a clear mental map. Psychologists sometimes describe this reaction using a concept called cognitive scale mismatch. Human perception works best when the environment fits within a scale that the brain can easily measure. When looking at a room, a street, or even a large building, the brain quickly calculates size and distance using familiar reference points. But environments that exceed those scales can become difficult to interpret. The deep ocean is one of the most extreme examples of this phenomenon. Not only does the water extend outward beyond visible limits, but it also continues downward into darkness that humans cannot easily visualize. A person standing at the ocean's edge might intellectually understand that the water becomes deeper, farther from shore, yet the mind struggles to picture what thousands of meters of depth actually look like. That gap between knowledge and visualization can produce a feeling of uncertainty, and uncertainty often triggers emotional responses. Another important psychological factor involves the human relationship with the unknown. Humans are naturally curious creatures. Throughout history, we have explored new lands, studied unfamiliar animals, and investigated mysterious natural phenomena. Curiosity drives learning and discovery. But curiosity also coexists with caution. When encountering environments that cannot be easily understood, the brain tends to increase alertness. This response evolved as a way to prevent individuals from walking blindly into potentially dangerous situations. The deep ocean represents one of the largest unknown environments on Earth. Even today, scientists estimate that more than 80% of the ocean remains unexplored in detail. Entire ecosystems exist in regions that humans have barely studied. New species continue to be discovered every year in deep-sea environments. This knowledge contributes to the psychological impact of the ocean's vastness. When people realize how much of the ocean remains mysterious, it reinforces the sense that the environment is fundamentally unknown, and the human mind often responds to unknown environments with a mixture of fascination and unease. Another psychological element behind thalassophobia involves the concept of perceived vulnerability. On land, humans have developed many strategies for protecting themselves. We can run, climb, hide, or seek shelter. Our bodies are adapted to move efficiently on solid ground. In water, especially deep water, many of those abilities become less effective. Movement slows down because swimming requires more energy than walking or running. Balance changes because the body floats rather than stands. Vision becomes distorted because water alters how light travels. These changes create a sense that the environment is less controllable. Psychologists sometimes refer to this as loss of environmental mastery. Environmental mastery describes the feeling that a person understands their surroundings and knows how to respond to potential challenges. When that feeling disappears, anxiety may increase. Floating in deep water can produce exactly that kind of sensation. A swimmer might realize that the bottom lies far below their feet. They cannot stand if they become tired. Their vision only extends a limited distance beneath the surface. Even if there is no immediate danger, the mind recognizes that the environment offers fewer options for control. This awareness can trigger a cautious emotional response. There is also a strong connection between thalassophobia and the way humans interpret darkness. Darkness has always carried psychological significance in human experience. Throughout evolutionary history, darkness limited visibility and increased the risk of encountering hidden dangers. As a result, humans developed a natural sensitivity to environments where light is limited. The deep ocean is one of the darkest environments on Earth. Sunlight only penetrates the upper layers of the ocean. At depths beyond 1,000 meters, natural light disappears entirely. The water becomes completely dark except for occasional flashes of bioluminescence from deep sea organisms. When people imagine this environment, they often picture endless darkness surrounding them in every direction. Even without entering the water, simply imagining that kind of darkness can trigger discomfort. The brain attempts to visualize the space, but cannot clearly define its boundaries. Darkness combined with depth creates a sense of infinite space where the mind cannot easily determine what might exist nearby. This psychological reaction is sometimes described as abyssal perception. Abyssal perception occurs when a person becomes aware of a space so deep or large that it challenges normal mental imagery. The brain attempts to construct a picture of the environment, but fails to create a stable representation. As a result, the space feels abstract and unsettling. Looking down into deep water often produces exactly this effect. The surface may appear calm and reflective, but the water beneath gradually fades into darkness. The mind tries to imagine the ocean floor far below, yet cannot easily visualize the distance. That gap between perception and imagination produces a feeling that something immense exists just beyond awareness. Interestingly, the same psychological response appears when humans encounter other extremely large environments. Looking up at a star-filled night sky can produce a similar sense of awe and disorientation. Standing near the edge of a massive canyon may create a feeling of vertigo as the brain struggles to interpret the vertical drop. These experiences are sometimes described using the term the sublime. The sublime refers to moments when humans encounter something so vast or powerful that it exceeds normal understanding. The experience often includes both wonder and discomfort. The deep ocean is a powerful example of this phenomenon. For some people, the vastness of the ocean produces calm or fascination. They feel drawn toward the mystery and beauty of the environment. For others, the same vastness creates anxiety. The difference often depends on how individuals interpret uncertainty. People who enjoy exploration may view unknown environments as opportunities for discovery. People who prefer predictability may interpret the same environments as potential sources of danger. Neither response is inherently right or wrong. They simply reflect different psychological tendencies. Another important aspect of thalassophobia involves the role of imagination. Humans possess an extraordinary ability to imagine scenarios that have not yet occurred. This ability allows us to plan, create, and solve complex problems, but imagination can also amplify fear. When a person looks into deep water and sees nothing beneath the surface, the brain may begin constructing possibilities. What might be down there? How deep does it go? What could be moving in that darkness? Even if the person understands that the likelihood of encountering something dangerous is extremely low, the mind may still generate vivid mental images. Psychologists call this process threat simulation. Threat simulation allows the brain to rehearse possible dangers in order to prepare for them. While useful in many situations, it can also produce anxiety when the imagined threats become more dramatic than the real environment. For example, a swimmer in clear coastal water may still imagine large predators lurking below, even if such animals are extremely rare in that region. The mind fills the unknown space with possibilities drawn from stories, movies, or cultural images of the ocean. Over time, repeated exposure to these imagined scenarios can strengthen the emotional response. A person who frequently visualizes the ocean as a place filled with hidden dangers may begin experiencing stronger reactions when encountering deep water. However, it is also possible for people to gradually reshape their perception of the ocean. Education, experience, and exposure can help the brain reinterpret unfamiliar environments. Divers who spend time exploring underwater environments often report that their initial fear gradually transforms into curiosity. As they learn more about marine life and underwater landscapes, the unknown becomes more familiar. The same vastness that once produced anxiety may eventually inspire fascination. This shift highlights an important truth about thalassophobia and many other fears. Fear is not fixed. It is shaped by experience, knowledge, and perception. When the brain understands an environment more clearly, uncertainty decreases. As uncertainty decreases, emotional responses often become calmer. Still, even experienced explorers sometimes feel a moment of awe when encountering the immense scale of the ocean. Looking into deep water reminds us that the world contains environments far larger and more mysterious than our everyday surroundings, and perhaps that reaction is not entirely negative. A sense of respect for powerful natural environments can encourage careful behavior and thoughtful exploration. The ocean, after all, is not just a place of mystery. It is also a place of extraordinary life, complex ecosystems, and scientific discovery. Understanding the psychology of thalassophobia helps explain why humans respond so strongly to the vastness of the sea. But it also reveals something deeper about the human mind. Our reactions to the unknown are shaped by both caution and curiosity. We feel uneasy when facing environments that challenge our understanding, yet we are also drawn toward those same environments in search of answers, and the deep ocean continues to invite that search. A place where darkness, depth, and imagination meet, shaping one of the most fascinating psychological experiences humans can encounter when looking into the water below. When people imagine the deep ocean, one of the first things that usually comes to mind is darkness. Not the gentle dimness of evening or the quiet shadows of a forest at dusk, but a kind of darkness that feels deeper and heavier. A darkness where sunlight cannot reach, where the water absorbs every remaining trace of brightness, and where visibility fades into something that looks almost like empty space. This darkness plays a powerful role in why the deep ocean can feel so unsettling to many people. Even individuals who are comfortable swimming in clear, shallow water sometimes feel a shift in their emotions the moment the water grows darker beneath them. It often happens gradually. A swimmer might start near the shore where the seabed is visible through pale green water. The sand reflects sunlight. Fish move between rocks, and the environment feels easy to understand. But as the swimmer moves farther from land, the colour of the water begins to change. The green fades into deeper blue. The bottom becomes harder to see. Then at some point the seabed disappears entirely, replaced by a darker shade of water that slowly fades into shadow. That is usually the moment when the brain notices something important. The environment has changed. Darkness, even partial darkness, alters how humans interpret their surroundings. Our vision is the primary sense we rely on to understand the world around us. When light levels decrease, the brain receives less information about distance, movement, and shape. As a result, the mind becomes more cautious. This reaction has deep roots in human biology. For most of human history, darkness often meant increased danger. Many predators are more active at night, and limited visibility makes it harder to detect threats before they get close. Because of this long evolutionary history, the human brain develops systems that respond strongly when light disappears. Scientists studying fear responses often refer to this as the uncertainty effect. When the brain cannot clearly observe an environment, it automatically assumes that hidden risks may exist. This does not mean those risks are actually present, but the brain prefers to prepare for the possibility rather than ignore it. The deep ocean creates exactly that type of uncertainty. Even during the daytime, sunlight only penetrates the upper layers of the sea. Water absorbs light very efficiently, especially as depth increases. The deeper the water becomes, the less light remains available. At roughly 200 meters below the surface, sunlight begins to fade dramatically. Colors disappear, shapes become faint, and the environment takes on a dark blue tone. Beyond 1,000 meters, natural sunlight disappears completely. From that point downward, the ocean becomes permanently dark. This region is often called the midnight zone. For humans, imagining a place where sunlight never reaches can be difficult. Our daily lives revolve around the cycle of day and night. Even nighttime on land is rarely completely dark because the moon, stars, and artificial lights provide some illumination. But the deep ocean does not experience those sources of light. The water above absorbs nearly all incoming sunlight. What remains is a darkness so complete that a person inside it would not be able to see their own hands without artificial lighting. When people visualize this environment, the mind often struggles to define its boundaries. If you close your eyes in a dark room, you still have a sense of where the walls and furniture are located. But imagine floating in water where darkness surrounds you in every direction. Above you lies a long column of water stretching toward the surface. Below you, thousands of meters of depth continue downward toward the seafloor. There are no visible walls, no ground beneath your feet, and no clear horizon. Just darkness and open space. The brain finds this situation difficult to interpret. Humans rely heavily on visual cues to understand spatial relationships. Without those cues, the mind must rely on imagination to fill in the missing information. And imagination can be unpredictable. Sometimes it generates neutral possibilities. Other times it produces more alarming scenarios. Psychologists often refer to this as ambiguity amplification. When sensory input becomes unclear, the brain increases its sensitivity to possible threats. Small movements or faint shapes become more noticeable. Sounds that might normally be ignored suddenly feel significant. Underwater darkness intensifies this effect. In shallow water with strong sunlight, it is usually easy to see fish or other marine animals approaching. The water is transparent enough that movement becomes visible well before it reaches the swimmer. In darker water, however, visibility may extend only a few meters. Beyond that distance, the water appears almost solid in colour. Anything moving through that space remains invisible until it comes closer. Even if nothing is actually there, the brain becomes aware of the possibility. Another factor that contributes to fear in dark water involves the way human vision evolved. Human eyes are designed primarily for daylight environments. Our ability to see colour and detail works best under bright conditions. While the eye can adjust to lower light levels, our night vision remains limited compared to many animals. Creatures such as cats, owls, and certain deep-sea fish possess eyes specifically adapted to detect faint light. Humans, by contrast, rely heavily on brightness to interpret shapes and motion. When brightness disappears, our visual confidence disappears with it. This is why even experienced swimmers sometimes feel uneasy in dark water. The brain recognizes that the environment has become visually unreliable, and when vision becomes unreliable, the mind tends to assume that hidden information might exist. Darkness also interacts with another powerful psychological process: anticipation. Humans are extremely good at anticipating future events. This ability allows us to plan ahead, prepare for challenges, and avoid potential dangers. But anticipation becomes more active when the brain encounters environments filled with unknown possibilities. For example, if a swimmer sees a large fish approaching from a distance, the brain can quickly identify the animal and evaluate whether it poses a threat. But if the water is dark and visibility is limited, The swimmer may anticipate something appearing unexpectedly from the darkness. Even if no creature actually appears, the brain continues preparing for that possibility. This state of anticipation can feel uncomfortable because it keeps the mind alert and slightly tense. The longer a person remains in that environment, the more noticeable the sensation may become. Interestingly, the deep ocean itself is not entirely silent or still. Although humans cannot hear most underwater sounds clearly without special equipment, the ocean contains a complex soundscape. Whales communicate across vast distances using low-frequency calls. Crustaceans produce clicking noises as they move along the seafloor. Currents shift water masses slowly across underwater landscapes. In shallow water, these sounds may be faint or barely noticeable. But in deeper environments, where visual information becomes limited, even subtle sounds can take on greater significance. The brain automatically tries to interpret unfamiliar noises. What caused that sound? How far away is it? Is it moving closer? These questions arise naturally when vision cannot provide clear answers. Another element that amplifies fear in dark water involves the human relationship with depth. Depth combined with darkness creates a powerful mental image. Looking into clear, shallow water allows the brain to see the seabed and estimate how far it lies below. Even if the water is several meters deep, the visible bottom provides reassurance that the environment is understandable. But once darkness hides the bottom completely, depth becomes abstract. The brain knows the ocean continues downward, but it cannot easily picture the distance. Imagine floating in water where the seafloor lies 3,000 meters below. That distance is difficult to visualize because humans rarely encounter vertical spaces of that scale. Even standing on a tall building rarely involves looking down more than a few hundred meters. The ocean's depth exceeds those scales dramatically. Darkness hides the details of that space, leaving only the knowledge that something immense exists below. For some people, this combination of darkness and depth creates a feeling that something could emerge from the unseen space. Even if logic suggests that the likelihood is extremely small, the imagination fills the darkness with possibilities. Cultural influences sometimes reinforce these ideas as well. Stories, films, and documentaries often portray the deep ocean as mysterious or dangerous. Images of large sea creatures moving through dark water can leave strong impressions on the mind. Over time, these images become associated with the mental picture of deep water. When a person later encounters dark ocean environments, those stored images may resurface. The brain remembers the stories and visual experiences it has encountered before, blending them with the present moment. But it is important to recognize that darkness in the ocean is not inherently threatening. For many marine animals, darkness is simply their natural environment. Deep-sea creatures have evolved remarkable adaptations that allow them to survive where sunlight never reaches. Some fish possess enormous eyes capable of detecting faint bioluminescent flashes. Others produce their own light using specialized organs called photophores. These lights may appear as glowing dots along the body, soft pulses of blue light, or complex patterns used to attract prey or communicate with other members of the species. In many ways, the deep ocean is not empty darkness at all. It is a hidden ecosystem filled with life, adapted to conditions very different from those on land. Scientists exploring these environments often describe them as strangely beautiful rather than frightening. Submersibles equipped with lights reveal landscapes of underwater mountains, strange coral formations, and drifting organisms that glow softly in the black water. But the human brain tends to focus first on the unknown. Darkness hides details that might otherwise feel reassuring, and when details disappear, the mind begins searching for explanations. This search can produce curiosity or anxiety depending on how the individual interprets the experience. For people who enjoy exploration, dark water may represent mystery waiting to be discovered. For people sensitive to uncertainty, it may represent a space where too many questions remain unanswered. Both reactions are natural. They simply reflect different ways the human brain responds to environments where light fades and imagination takes over. The deep ocean remains one of the few places on Earth where darkness still dominates completely, and when humans look into that darkness from the surface, it reminds us how much of the planet remains hidden beneath the waves. When people look out across the ocean, the surface often appears simple and calm. From the shoreline, it may look like a flat sheet of water stretching toward the horizon. Waves move rhythmically, sunlight glitters across the surface, and the water can seem almost peaceful in its stillness. But that calm surface hides something unusual about the way the ocean interacts with human perception. The ocean does not just contain depth, it also disguises depth in ways that the human brain finds difficult to interpret. On land, most environments provide clear visual clues that help us estimate distance and size. Trees stand upright against the sky. Hills and mountains create layers of terrain. Roads and buildings offer familiar shapes that the brain can compare against objects we already understand. When you look across a valley, your mind quickly calculates how far away the opposite side might be. Even if the estimate is not perfectly accurate, the brain still builds a rough mental map of the environment. Water removes many of those visual references. When you look out across the ocean, there are almost no fixed objects to measure distance against. The surface reflects the sky and changes colour depending on the weather, the time of day, and the depth below. From the shoreline, the water may appear shallow and transparent, especially in clear coastal regions where sunlight reaches the seabed. You might see sand ripples on the bottom or small fish swimming between rocks, but move only a short distance away from the shore and that clarity begins to change. The colour deepens, the bottom fades, eventually the seabed disappears entirely. At that point, the water begins to play subtle tricks on the human visual system. One of the first illusions comes from the way light behaves underwater. Sunlight enters the ocean at an angle and spreads through the water column. As it travels downward, different wavelengths fade at different speeds. Red light disappears quickly, followed by orange and yellow. Blue wavelengths penetrate farther, which is why deep water appears blue from the surface. This colour shift can distort how the brain interprets depth. Water that is only a few meters deep may already appear dark blue if the seabed absorbs light instead of reflecting it. Conversely, shallow water above bright sand may look lighter and appear deeper than it actually is. The brain attempts to interpret these colour differences as signals about depth, but the signals are not always reliable. Another illusion involves the transparency of water itself. Clear water can give the impression that objects are closer than they really are. Divers often notice this effect when looking at underwater formations or animals. Something that appears only a few meters away may actually be much farther. This phenomenon occurs because water alters how light bends as it travels toward the eye. The bending of light slightly magnifies objects and shifts their apparent position. As a result, the brain may underestimate distance. In shallow environments, this effect may not be particularly noticeable. But when the seabed lies far below the surface, the illusion becomes stronger. A swimmer floating above deep water might glance downward and see only faint variations in colour. The brain may interpret those variations as indicating moderate depth. In reality, the ocean beneath them could extend for hundreds or thousands of meters. The mind struggles to visualize such extreme vertical space. This difficulty arises partly because humans rarely encounter large vertical environments in everyday life. On land, even tall buildings or mountains rarely exceed a few thousand meters in height. The human brain developed ways to estimate these distances using familiar reference points such as trees, rocks, and slopes. The ocean removes those reference points entirely. Imagine floating in water where the seabed lies 3,000 meters below your feet. There are no visible objects marking that distance. The water simply becomes darker as it descends. Without clear visual anchors, the brain cannot easily measure the depth. This lack of measurement produces a strange mental effect. The mind recognizes that something enormous exists beneath the surface, yet it cannot construct a clear image of what that space actually looks like. Psychologists sometimes describe this as spatial ambiguity. Spatial ambiguity occurs when the brain cannot confidently determine the size or boundaries of an environment. In response, the mind becomes more alert and cautious. This is one reason why looking into deep water can produce an uneasy sensation. The brain knows that depth exists but cannot see its limits. Another illusion emerges from the way the ocean surface behaves. Waves and reflections constantly shift the appearance of the water. Sunlight bouncing off the surface creates bright flashes and moving patterns that distract the eye from looking deeper. These reflections act almost like a mirror, hiding details beneath the water. If you stand on a dock or boat and look down into the sea, you may notice how reflections of clouds or sunlight obscure the view below. Sometimes the surface looks almost solid. Other times it appears transparent for a brief moment when the light angle changes. This constant shifting prevents the brain from forming a stable image of what lies beneath. Even in relatively shallow water, the seabed may appear and disappear depending on the movement of waves and the direction of sunlight. The mind tries to interpret these glimpses, but the picture remains incomplete. In deeper water, where the bottom lies far beyond visible range, the effect becomes even more pronounced. The surface shows only reflections and subtle variations in colour. Everything below remains hidden. For many people, this hidden space becomes the focus of imagination. The brain attempts to fill in the missing information. How deep does it go? What might be moving beneath the surface? Is the water empty or filled with unseen life? Because the mind cannot see the answer directly, it generates possibilities. Sometimes those possibilities are neutral or curious. Other times they lean toward caution or fear. Another factor that contributes to the illusion of depth involves the way humans perceive movement in water. Objects underwater often move slowly due to the resistance of the water itself. Fish glide gently through currents. Plants sway back and forth with the motion of waves. These slow movements can distort the brain's perception of size and distance. A small fish swimming close to the surface may appear larger if the brain interprets its slow movement as something farther away. Similarly, a large object deeper in the water may appear smaller because the brain assumes it is closer than it really is. These visual distortions make it difficult to judge scale accurately. Divers often report feeling surprised when approaching underwater formations that initially looked small from a distance, but turned out to be enormous once they swam closer. The ocean environment constantly alters the visual signals the brain relies on for orientation. Because of this, even experienced swimmers sometimes misjudge the distance between themselves and other objects in the water. Visibility also plays an important role. Water clarity varies widely depending on location, weather, and environmental conditions. In tropical regions with minimal sediment, visibility can extend for dozens of meters. In coastal waters with more particles suspended in the water, visibility may drop to only a few meters. When visibility becomes limited, the brain receives even less information about the environment. Shapes fade into the surrounding water more quickly. Movement becomes harder to detect. The mind must rely on incomplete visual clues to interpret what is happening. This situation increases the sense of uncertainty that many people experience when looking into deep water. Even if the water is calm and nothing unusual is present, the lack of clear information makes the environment feel unpredictable. Another interesting aspect of ocean perception involves the horizon. When standing on land, the horizon usually contains landmarks such as hills, buildings, or trees. These objects help the brain understand distance and orientation. But when looking out across open water, the horizon often appears as a simple line where the sky meets the sea. This line can stretch across hundreds of kilometers without interruption. The simplicity of the ocean horizon creates a feeling of vastness that the brain rarely encounters elsewhere. There are no intermediate landmarks to break up the space, just sky above and water below. This visual simplicity can make the ocean feel much larger than it actually appears. It also removes many of the cues the brain normally uses to determine scale. Without these cues, the mind may exaggerate the perceived size of the environment. For some people, this vastness produces a sense of calm and openness. For others, it contributes to the feeling that the ocean is too large to fully understand. This psychological response connects closely to the fear of the unknown. When the brain cannot clearly define the boundaries of a space, it often assumes that hidden elements may exist beyond sight. Deep water encourages exactly that type of thinking. The ocean's surface hides enormous vertical spaces where sunlight fades and details disappear. The brain recognizes that something lies beneath but cannot easily picture what that space looks like. This gap between perception and imagination creates one of the most distinctive features of thalassophobia. The ocean does not merely contain depth. It disguises depth in ways that challenge the human visual system. What appears calm and simple on the surface may extend downward for kilometers. The water reflects light, distorts shapes, and removes familiar reference points. As a result, the mind must interpret an environment where the usual rules of perception no longer apply. Some people respond to this illusion with curiosity, wanting to explore what lies beneath. Others feel a quiet tension when looking into the blue water and realizing how little of it can actually be seen. Both reactions reveal something fascinating about the human brain. We rely on visual information to understand the world around us, and when that information becomes incomplete, the mind becomes aware that it is standing at the edge of something far larger than it can easily imagine. The ocean does not simply hide its depth. It transforms depth into mystery, inviting the imagination to wander into spaces where the eye cannot follow. When people imagine the deep ocean, their thoughts rarely stop at darkness or depth alone. Very quickly the mind moves toward another question that feels almost unavoidable. What lives down there? For many individuals, this question is where fascination begins to blend with unease. The ocean is not an empty space. It is home to an enormous variety of life, much of which exists far beyond the reach of sunlight. Some of these creatures appear familiar, resembling fish or animals that humans recognize from shallow waters. Others look so unusual that they seem almost unreal. For someone already uneasy about deep water, the idea of unknown creatures moving through that darkness can amplify the sense of fear. But the interesting part is not simply the creatures themselves. The deeper reason behind this reaction lies in how the human brain responds to unfamiliar life forms. Humans evolved in environments where animals generally followed recognizable patterns. Most mammals share similar body structures: 4 limbs, a head, eyes positioned toward the front, and movement that can be predicted once the species is known. Birds fly with wings, reptiles crawl or slither, and insects move in ways that people quickly learn to recognize. Over time, the human brain developed a strong ability to categorize animals based on these patterns. When we see a dog, deer, or horse, our minds immediately understand how the animal moves and what behavior to expect. Even animals that are dangerous, such as lions or wolves, follow patterns that humans have studied for thousands of years. Marine life, especially deep sea life, often breaks these patterns. Fish may have elongated bodies, translucent skin, or unusually large mouths. Some creatures possess glowing organs that emit light. Others move slowly through the water using delicate fins or tentacles that drift like threads in the current. Because these features do not resemble familiar land animals, the brain has difficulty placing them into known categories. Psychologists refer to this as morphological unfamiliarity. When the brain encounters a living creature whose structure does not match previously known patterns, it becomes more cautious. The mind cannot easily predict how the animal will behave or what it might do next. This uncertainty increases attention and sometimes produces discomfort. The deep ocean contains many examples of such unfamiliar forms. Take the anglerfish, for instance. This deep-sea predator lives in darkness hundreds of meters below the surface. It possesses a glowing lure that extends from its head, which it uses to attract prey in the dark water. To a human observer, the anglerfish can appear strange and even frightening. Its large teeth, wide mouth, and glowing lure create an image that feels unfamiliar compared to animals people see on land. Yet from a biological perspective, the anglerfish is simply a predator adapted to a dark environment where food is scarce. The glowing lure functions as a clever hunting tool, drawing smaller fish toward the anglerfish's mouth. Another example comes from deep-sea squid. Some species possess enormous eyes designed to detect faint traces of light in the darkness. Others have long, flexible tentacles that can extend rapidly to capture prey. These features may look unusual to humans because they evolved under conditions very different from those experienced on land. In deep water, where sunlight never reaches and food may be scarce, animals must develop specialized adaptations to survive. Large eyes help detect faint bioluminescent flashes produced by other organisms. Flexible bodies allow animals to move efficiently through dense water. Light-producing organs may help attract prey or communicate with other members of the species. All of these adaptations make sense in the deep ocean environment, but when humans encounter images of these animals, the unfamiliar shapes can trigger a psychological reaction. Another factor contributing to fear of deep-sea creatures involves scale. The ocean contains animals that vary dramatically in size. Some are tiny organisms smaller than grains of sand. Others are enormous creatures capable of reaching lengths greater than several buses placed end to end. One of the most famous examples is the giant squid. For centuries, sailors reported encounters with enormous tentacled animals rising from the depths. These stories often sounded exaggerated or mythical. Only in the last century did scientists confirm that giant squid truly exist, living far below the ocean surface. The largest recorded individuals measure more than 10 meters in length, with tentacles lined with powerful suction cups. Although giant squid rarely interact with humans, their existence adds to the perception that the deep ocean contains creatures far larger than most people expect. The idea that such animals move through dark water can be unsettling for those who already feel uneasy about deep environments. However, it is important to remember that most deep-sea creatures are not dangerous to humans. Many species are delicate animals, adapted to specific pressure conditions. If brought to the surface, they often cannot survive because their bodies are built to withstand immense pressure found only at great depths. This pressure is another reason deep-sea life appears so unusual. At depths of several thousand meters, the pressure becomes hundreds of times greater than at the ocean surface. Every square centimeter of an animal's body must withstand the weight of water above it. To survive in such conditions, deep-sea animals have evolved flexible tissues and unique body structures. Some fish lack rigid skeletons, allowing them to adapt to the crushing pressure without damage. Others possess gelatinous bodies that help them remain buoyant in deep water. These adaptations may make the animals appear fragile or strange when observed by human eyes, but they are simply solutions to the environmental challenges of deep ocean life. Bioluminescence adds another layer of mystery to these creatures. Many deep-sea organisms produce their own light through chemical reactions inside specialized organs. This light can appear as glowing dots, flashes, or waves of color moving through the water. Scientists believe bioluminescence serves several purposes. Some animals use light to attract prey. Others use it to confuse predators or communicate with members of their own species. In the dark ocean environment, light becomes a powerful tool for survival. For humans observing from submersibles or cameras, these glowing creatures can look both beautiful and unusual. A small jellyfish drifting through black water might pulse with soft blue light. Tiny plankton may sparkle like distant stars when disturbed. These displays reveal that the deep ocean is far from empty darkness. It is a vibrant ecosystem filled with organisms interacting in ways that scientists are still trying to understand. Yet the unfamiliar nature of these creatures continues to influence how people perceive the deep ocean. Human psychology tends to interpret unfamiliar biological features as potential warning signs. Large teeth, unusual body shapes and glowing organs may signal danger in the mind even when the animal itself poses no threat. This reaction is closely related to the brain's pattern recognition system. Throughout evolutionary history, humans learned to identify animals based on certain visual cues. Sharp teeth might indicate a predator, bright colours might suggest toxicity, large eyes might signal an animal adapted for nighttime hunting. When deep-sea creatures display combinations of these features in unfamiliar ways, the brain may interpret them as threatening even if they are harmless. Media and storytelling have also shaped the way people imagine marine life. Movies, books, and documentaries often emphasize the mysterious aspects of deep-sea creatures. Images of enormous tentacles, glowing predators, or shadowy figures moving through dark water can create powerful impressions. These images become part of the cultural narrative surrounding the ocean. When people later encounter real footage of deep-sea animals, their reactions may be influenced by those earlier impressions. The mind recalls stories and images associated with the ocean's depths. As a result, the presence of unknown marine life can amplify feelings of unease for individuals who already feel uncertain about deep water. But scientists studying the ocean often emphasize a different perspective. To them, deep-sea creatures represent one of the most fascinating areas of biological research. Each new species discovered reveals information about how life adapts to extreme conditions. Studying these organisms helps scientists understand evolution, ecology, and the limits of life on Earth. Some deep-sea organisms even produce chemicals that researchers believe may have medical applications. Compounds found in certain marine species are being studied for their potential use in treating diseases or developing new pharmaceuticals. This means that the creatures once feared for their strange appearance may eventually contribute to advances in human medicine. Exploration of the deep ocean continues to reveal new forms of life. Robotic submersibles and remote cameras allow scientists to observe animals living at depths that were once impossible to reach. Each expedition brings the possibility of discovering species never seen before. The ocean remains one of the most biologically diverse environments on Earth. Thousands of species inhabit its depths, many of which have not yet been documented. For those who experience thalassophobia, the idea of unknown creatures may remain unsettling. But for researchers and explorers, these animals represent the extraordinary creativity of evolution. Life has adapted to darkness, pressure, and isolation in ways that challenge our understanding of biology. The deep ocean is not simply a place filled with frightening creatures. It is a vast living world where organisms survive under conditions that humans are only beginning to explore. And while the unfamiliar forms of deep-sea animals may trigger fear in some people, they also remind us of something remarkable. The planet we live on still contains mysteries waiting to be discovered, hidden far below the waves where sunlight never reaches and life continues to evolve in silence. If someone were able to descend slowly through the ocean, starting from the bright surface and moving deeper and deeper, the transformation would happen gradually at first. The upper layers of the sea feel familiar. Sunlight filters through the water, illuminating drifting particles and schools of fish moving through clear blue space. The surface waves above ripple softly, and the environment still resembles something the human mind can easily understand. But as the descent continues, the ocean begins to change in ways that are subtle yet unmistakable. The light weakens, colours fade. The brightness that once filled the water becomes softer, then dimmer, and eventually begins to disappear altogether. This transition leads into one of the most unusual environments on Earth, a region of the ocean where sunlight no longer exists. Scientists refer to this vast region as the Abyssal zone, a place so deep that the sun has no influence on the world below. To understand how this environment forms, it helps to consider how sunlight travels through water. When sunlight strikes the surface of the ocean, a portion of it reflects back into the atmosphere. The remaining light enters the water and begins moving downward through the ocean column, but seawater absorbs light very effectively. Each metre of depth removes a small fraction of the sunlight. At first, the effect is barely noticeable. Within the first few metres beneath the surface, the water still appears bright and clear. Divers swimming in shallow tropical waters can easily see coral reefs, fish, and underwater landscapes illuminated by strong sunlight. But as depth increases, the filtering process becomes more dramatic. By the time a diver reaches around 100 metres below the surface, most of the red wavelengths of sunlight have already disappeared. Objects that would normally appear red now look dark grey or black, because the light required to display those colours no longer exists. As the descent continues past 200 metres, orange and yellow light fades as well. Blue light penetrates farther than other wavelengths, which is why deep ocean water often appears deep blue when viewed from above. However, even blue light cannot travel indefinitely through seawater. By the time a depth of 1,000 metres is reached, nearly all sunlight has been absorbed. Beyond that point begins a world of permanent darkness. The abyssal zone generally refers to depths between about 3,000 and 6,000 metres below the surface. At these depths, sunlight has been absent for thousands of years. The environment remains dark every moment of every day. For creatures living there, the sun is not part of their experience at all. They exist in a world where darkness is the normal condition. For humans trying to imagine this place, the concept can feel difficult to grasp. Even nighttime on land rarely produces complete darkness. The moon, stars, and artificial lights provide some level of illumination. Human cities glow brightly enough that they can be seen from space. But the abyssal zone receives none of that light. The water above absorbs nearly every photon long before it reaches those depths. The result is a darkness so complete that a person standing there without artificial lighting would not be able to see anything at all. This environment extends across enormous areas of the ocean floor. In fact, the abyssal zone covers a large portion of Earth's surface. The seafloor at these depths is often composed of vast plains of sediment, gently rolling landscapes formed by particles that slowly settle from the upper layers of the ocean. These particles include fragments of dead plankton, tiny shells, and organic material drifting down from the sunlit surface waters far above. Over thousands and millions of years, these particles accumulate, creating a soft blanket of sediment across the abyssal plains. Despite the darkness and cold, life still exists there. Creatures adapted to this environment move slowly across the seafloor or drift through the water column above it. Many animals have evolved unique strategies for surviving in a place where food is scarce and light does not exist. Some fish possess enormous mouths and expandable stomachs that allow them to swallow prey nearly as large as themselves. Because meals may be rare in the deep ocean, these adaptations help them take advantage of any opportunity to feed. Other animals move slowly to conserve energy. Deep-sea starfish crawl across the sediment searching for organic particles that fall from above. Sea cucumbers glide across the seafloor, filtering nutrients from the mud. Small crustaceans scurry along the bottom, looking for scraps of food drifting down through the water. The entire ecosystem of the abyssal zone depends heavily on what scientists call marine snow. Marine snow is a continuous shower of tiny organic particles that drift downward from the upper layers of the ocean. These particles include fragments of dead plankton, microscopic algae, fish waste, and other biological debris. As these materials slowly fall toward the seafloor, they provide food for many deep-sea organisms. Although the name marine snow may sound delicate, this process plays a crucial role in sustaining life in the abyss. Without the steady rain of organic matter from above, most deep-sea ecosystems would struggle to survive. Another defining feature of the abyssal zone is pressure. The deeper a person travels beneath the ocean's surface, the greater the pressure exerted by the water above. Pressure increases rapidly with depth. At just 10 meters below the surface, the pressure has already doubled compared to conditions on land. By the time a depth of 1,000 meters is reached, the pressure becomes 100 times greater than at the surface. In the abyssal zone, Where depths may reach 4,000 or 5,000 meters, the pressure becomes enormous. Every square centimeter of an object's surface experiences thousands of kilograms of force. Human bodies cannot survive these conditions without specialized equipment. Submersibles designed to explore the abyss must be constructed from extremely strong materials capable of withstanding crushing pressure. Yet the animals living in these depths have adapted perfectly to the environment. Their bodies contain flexible tissues and specialized structures that allow them to function under immense pressure. Many deep-sea fish lack rigid skeletons, which helps them avoid structural damage from the surrounding water. Some organisms even rely on the pressure itself to maintain the stability of their internal systems. If brought to the surface too quickly, these animals may not survive because the drastic reduction in pressure disrupts their biological balance. Temperature also shapes the abyssal environment. Far below the sunlit surface, the ocean becomes extremely cold. Temperatures in the abyssal zone typically hover around 2 to 4 degrees Celsius. This cold environment slows the metabolism of many deep-sea organisms. Animals move more slowly, conserve energy, and grow at a much slower rate compared to creatures living in warmer waters. Some deep-sea species may live for decades or even centuries due to their slow biological processes. Despite the darkness, the abyssal zone is not completely devoid of light. Many organisms produce their own illumination through bioluminescence. Chemical reactions inside specialized cells generate flashes or glows of light that animals use for various purposes. Some creatures use bioluminescent signals to attract prey. Others use light displays to communicate with members of their species. In certain cases, animals even use light to hide themselves. Some fish produce faint light along their bellies that matches the brightness of the faint glow filtering down from above. This technique, known as counter-illumination, helps them blend into the environment when viewed from below. The presence of these glowing organisms means that the abyssal zone occasionally sparkles with tiny flashes of light moving through the darkness. For scientists exploring the deep ocean with cameras and submersibles, these glowing creatures create scenes that look almost like stars drifting through space. Yet despite these remarkable adaptations, the abyssal zone remains one of the least explored regions on Earth. The extreme pressure, darkness, and vast size of the deep ocean make exploration difficult and expensive. Only a small number of manned submersibles are capable of reaching these depths. Most scientific exploration relies on remotely operated vehicles equipped with cameras and robotic arms. These machines descend thousands of meters beneath the surface, transmitting images of landscapes and animals that few humans have ever seen. Each expedition reveals new species and geological formations. Underwater mountains rise from the seafloor. Volcanic vents release superheated water rich in minerals. Strange creatures glide slowly through the black water, adapted perfectly to conditions that would be fatal to most surface life. For people who experience thalassophobia, imagining this environment can be unsettling. The idea of endless darkness combined with immense pressure and unfamiliar life forms may reinforce the feeling that the deep ocean is an alien world. But for scientists and explorers, the abyssal zone represents one of the most fascinating frontiers of discovery. It's a place where life has adapted to conditions that seem almost impossible, where ecosystems thrive without sunlight, and where the planet still holds countless mysteries waiting to be understood. The abyssal zone reminds us that the ocean is not simply a large body of water. It is a vast three-dimensional environment stretching downward into depths where sunlight disappears forever, leaving behind a silent world shaped by darkness, pressure, and the quiet persistence of life. As scientists began exploring the deeper parts of the ocean, they started noticing something unusual about certain animals living there. Many deep-sea creatures seem to grow far larger than their relatives living close to the surface. Crabs with legs stretching wider than a dinner table. Jellyfish with bells broader than a car tyre. Squid whose tentacles could extend longer than a city bus. Even tiny organisms such as amphipods, which resemble small shrimp, sometimes grow to sizes several times larger than similar species living in shallow water. At first, this pattern confused researchers. Why would animals living in an environment where food is scarce and conditions are extreme grow to such enormous sizes? The phenomenon eventually became known as deep-sea gigantism, and it remains one of the most fascinating biological patterns observed in the ocean. But to understand why it happens, it helps to look at how life in the deep ocean operates under very different rules compared to life on land or near the surface. The deep ocean is a world of cold temperatures, immense pressure, and very limited food. These conditions may seem hostile, but they also create an environment where certain biological strategies become surprisingly effective. One of the most important factors influencing body size in the deep ocean is temperature. Water in the abyssal and bathyal zones is extremely cold, usually hovering just a few degrees above freezing. Cold temperatures slow down the chemical reactions that occur inside living cells. For many animals, this means their metabolism operates more slowly. A slower metabolism affects nearly every aspect of an organism's life. Growth takes longer, movement becomes slower, energy is used more efficiently. While this might sound like a disadvantage, it can actually allow certain animals to grow larger over time. On land, animals with slow growth rates often face intense competition or predation before they can reach large sizes. But in the deep ocean, predators are relatively rare, and many animals move slowly due to the cold. This means that an organism capable of surviving for long periods may continue growing gradually for many years. Over time, the result can be individuals that reach surprisingly large sizes. Another factor that contributes to deep-sea gigantism involves oxygen availability. Cold water holds more dissolved oxygen than warm water. In the deep ocean, oxygen levels can remain relatively stable across large regions. Some scientists believe that these higher oxygen concentrations may allow certain animals to support larger body structures. In crustaceans, for example, oxygen travels through the body using a system of tubes that distribute air to tissues. Larger animals require more oxygen to maintain their internal processes. In oxygen-rich environments, these systems may function efficiently even as the animal grows larger. This helps explain why some deep-sea crustaceans, such as giant isopods, grow to sizes far larger than their shallow water relatives. A typical isopod living near the shore might be only a few centimeters long. In the deep ocean, however, some species can reach lengths of over 30 centimeters, resembling armored creatures from another era. When these animals were first discovered, scientists were astonished by their appearance. The giant isopod looks like an enormous pill bug, with overlapping plates covering its body and large segmented legs extending from its underside. Despite their intimidating appearance, these creatures are mostly scavengers. They crawl slowly across the ocean floor, searching for organic material that drifts down from above. A dead fish, whale carcass, or other large food source may attract dozens of these animals, each competing for a rare opportunity to feed. Because meals in the deep ocean can be infrequent, giant isopods possess an unusual ability. They can survive for extremely long periods without eating. Some individuals have been observed living for years between meals. This slow lifestyle fits well with the deep ocean environment, where energy must be conserved carefully. Another famous example of deep-sea gigantism appears in squid. The colossal squid and the giant squid are two species that have captured human imagination for centuries. Stories of enormous tentacled creatures rising from the depths were once considered myths told by sailors. Today, scientists know that these animals truly exist. The giant squid can reach lengths of more than 10 meters, while the colossal squid may weigh even more due to its thicker body and powerful tentacles. These squid live in deep ocean waters where sunlight rarely reaches. Their large eyes help them detect faint movement in the darkness, allowing them to locate prey or avoid predators. In fact, the eyes of the colossal squid are among the largest known in the animal kingdom, sometimes measuring more than 25 centimeters across. The size of these eyes allows the squid to detect even small changes in light, produced by bioluminescent organisms or distant animals moving through the water. This ability is especially important in an environment where visibility is extremely limited. Large body size may also provide advantages when hunting or defending against predators. A bigger animal can capture larger prey and may be less vulnerable to certain threats. In the deep ocean, where encounters with food may be rare, the ability to consume large prey becomes particularly valuable. But gigantism does not occur in every deep-sea species. Many animals remain small, delicate, and nearly transparent. The deep ocean contains an incredible diversity of body sizes, each adapted to different ecological niches. Some jellyfish grow extremely large because their gelatinous bodies require relatively little energy to maintain. Their slow drifting movement allows them to cover large areas while capturing small prey suspended in the water. Other creatures adopt the opposite strategy, remaining tiny and conserving energy by feeding on microscopic particles. Both approaches can succeed in an environment where resources are unpredictable. Pressure also influences body structure in the deep ocean. At depths of several thousand meters, the pressure becomes hundreds of times greater than at the surface. Animals living in these conditions must have flexible tissues that can withstand the immense force of the surrounding water. Rigid structures such as air-filled cavities become impossible to maintain. Instead, many deep-sea animals develop soft bodies filled with fluid that matches the pressure of the surrounding environment. This design prevents their bodies from being crushed. In some cases, these adaptations also allow animals to grow larger, because their bodies do not rely on heavy skeletal structures. Instead, they float or move slowly through the water with minimal resistance. The strange shapes of many deep-sea creatures often reflect these adaptations. Long limbs, oversized mouths, and delicate fins may appear unusual to human observers, but each feature serves a specific function in the deep ocean ecosystem. A large mouth may allow a fish to capture any prey it encounters, since food opportunities are rare. Extended limbs may help crustaceans sense vibrations in the sediment as they search for food. Bioluminescent organs may attract prey or signal other members of the species in the darkness. From a human perspective, these animals may look strange or even frightening. But in reality, they are simply highly specialized organisms that have evolved to survive in one of the most extreme environments on Earth. The deep ocean remains one of the least explored ecosystems on the planet. Scientists estimate that thousands of species living in these depths have yet to be discovered. Each new expedition using deep-sea submersibles or remotely operated vehicles often reveals creatures that researchers have never seen before. Some resemble animals already known to science, but display surprising differences in size or structure. Others appear so unusual that they require entirely new classifications. These discoveries continue to reshape our understanding of life on Earth. They show that evolution can produce extraordinary solutions when organisms face unusual environmental challenges. Deep-sea gigantism is just one example of how life adapts to conditions that seem almost impossible. For people who experience thalassophobia, the existence of such large and unfamiliar animals may intensify the feeling that the ocean hides strange and mysterious creatures. The idea of enormous animals moving through dark water can easily capture the imagination. But it is important to remember that most of these animals live far below the depths where humans normally swim or travel. Encounters between humans and deep-sea creatures are extremely rare. Most species remain hidden in environments that human bodies cannot easily reach. For scientists and explorers, these creatures represent something remarkable. They demonstrate the incredible flexibility of life and its ability to adapt to conditions that differ dramatically from those found on land. In the silent darkness of the deep ocean, evolution has shaped animals that grow slowly, live quietly, and sometimes reach astonishing sizes. Their strange forms remind us that the ocean is not merely a vast body of water, it is a living world where biology continues to experiment, creating creatures that challenge our expectations and reveal how diverse life on Earth can truly be. When most people imagine the deep ocean, They often picture a silent world, a place of darkness and stillness where creatures drift quietly through cold water far below the surface. The images people see in documentaries or photographs reinforce this idea. A submersible descends slowly into black water. Strange fish glide past the camera. Sediment rests undisturbed on the sea floor. Everything appears calm and quiet. But the ocean is not silent at all. In fact, the ocean is one of the most acoustically active environments on Earth. Beneath the surface exists a vast network of sounds travelling across enormous distances, creating what scientists sometimes describe as the soundscape of the sea. For humans on land, sound behaves in familiar ways. Voices travel through air, footsteps echo through hallways, thunder rolls across the sky during storms. But water changes how sound moves in ways that make the ocean a completely different acoustic environment. The most important difference lies in how efficiently water carries sound. Sound waves travel much faster in water than they do in air. In the atmosphere, sound typically moves at about 340 meters per second. In seawater, the speed increases to roughly 1,500 meters per second, more than 4 times faster. Water is also denser than air, which means sound waves lose less energy as they travel. The result is that sound can move across extremely long distances underwater. A noise produced in one part of the ocean may travel hundreds or even thousands of kilometers before fading completely. This property makes sound one of the most important ways animals communicate and navigate in the ocean. In many ways, the deep sea operates less like a visual environment and more like an acoustic one. Light disappears quickly beneath the surface, especially at great depths. Darkness limits how far animals can see, making vision less reliable for detecting other creatures or obstacles. Sound, however, remains effective even in complete darkness. Because sound travels so well through water, many marine animals rely heavily on it for communication and awareness of their surroundings. Whales provide one of the most remarkable examples. Some species produce deep, low-frequency calls that travel enormous distances through the ocean. Blue whales, the largest animals ever known to exist, create sounds that can be detected hundreds of kilometers away. These calls allow whales to communicate with other members of their species, even when they are separated by vast stretches of water. Scientists studying whale communication have discovered that some populations appear to maintain acoustic contact across entire ocean basins. One whale calling in the distance may receive a response from another whale far beyond the limits of human hearing. The ocean carries those sounds through layers of water where temperature and pressure create natural channels that guide sound waves across long distances. This phenomenon forms what researchers call the deep sound channel. Within certain layers of the ocean, sound waves become trapped between regions of different water density. Instead of spreading upward or downward, the sound travels horizontally through the channel with minimal energy loss. This allows certain whale calls to travel incredibly far. For animals living in the deep ocean, these acoustic pathways act almost like invisible communication highways. But whales are not the only animals contributing to the ocean soundscape. Dolphins produce rapid clicking sounds used for echolocation. These clicks bounce off objects and return to the dolphin's ears, allowing the animal to build a detailed mental image of its surroundings. Echolocation works especially well underwater, because sound waves reflect clearly off solid surfaces such as fish, rocks, or the ocean floor. With this ability, dolphins can detect prey hidden in murky water and navigate complex underwater environments even when visibility is extremely poor. Some dolphins are capable of identifying objects based solely on the echoes returning from their clicks. Fish also contribute to the ocean's hidden orchestra. Although many people assume fish are silent, numerous species produce sounds using specialized structures in their bodies. Some fish vibrate muscles against their swim bladders to create drumming noises. Others grind teeth or rub body parts together to generate clicking sounds. These noises may serve many purposes. Some fish use sound to attract mates during breeding seasons. Others use it to establish territory or warn away rivals. On coral reefs, the combined noises of fish and crustaceans create a constant crackling sound that researchers sometimes describe as underwater applause. Even small organisms add to the ocean's acoustic environment. One of the most common sounds in shallow marine habitats comes from snapping shrimp. These tiny crustaceans possess specialized claws capable of producing sharp, snapping noises. When the claw closes rapidly, it creates a bubble that collapses with surprising force, generating a loud clicking sound. In large groups, snapping shrimp produce a steady crackling noise that can dominate the underwater soundscape. In some coastal regions, the combined snapping sounds of thousands of shrimp create a background noise strong enough to interfere with sonar equipment used by submarines. Deep in the ocean, the soundscape changes again. The darkness of the abyssal zone may appear still to the human eye, but subtle sounds continue to travel through the water. Slow movements of animals produce faint vibrations. Underwater landslides shift sediment along the seafloor. Even the movement of ocean currents generates low-frequency noise as water masses slide past one another. Some deep-sea fish produce faint calls that scientists are only beginning to study. These calls may serve as signals between individuals scattered across the dark ocean floor. Because sound travels so efficiently underwater, even quiet signals may carry farther than expected. For humans exploring the deep ocean, these sounds remain mostly hidden. Divers and submersible crews rarely hear them directly without specialized listening equipment, but underwater microphones, known as hydrophones, reveal the rich acoustic environment that surrounds marine life. Hydrophones allow researchers to record the sounds of whales migrating across oceans, dolphins hunting in groups, and fish communicating along reefs. These recordings show that the ocean contains layers of acoustic activity operating constantly. In many places, the soundscape shifts depending on time of day, season, or location. Certain fish produce calls only during specific breeding periods. Whale songs change over time as populations alter their vocal patterns. Even the sound of waves breaking on distant shorelines may travel far beneath the surface. Yet this hidden language of the ocean also plays an important role in shaping human perception of the deep sea. For people who feel uneasy about deep water, the idea that the ocean contains sounds travelling through darkness can amplify the sense that something unseen might be nearby. Imagine floating in water where visibility extends only a few meters. The water below fades into darkness. Then you hear a faint vibration or distant noise moving through the water. Even if the sound is harmless, the brain immediately begins searching for its source. What made that sound? How far away is it? Is it approaching? These questions arise naturally when sensory information is incomplete, because humans rely heavily on vision. Environments where sound becomes the primary source of information can feel unfamiliar. On land, we usually see what produces a noise. A bird calls from a tree. A car passes along the road. Footsteps echo in a hallway. Underwater, the source of sound may remain hidden. Sound travels farther and faster in water, meaning a noise may originate from far beyond visible range. For the human brain, this creates another layer of uncertainty. The ocean becomes not only dark, but also filled with signals that cannot be easily interpreted. In reality, these sounds form a vital communication network among marine animals. Whales use sound to maintain social connections across vast distances. Dolphins rely on echolocation to explore their environment. Fish and crustaceans create signals that help them find mates, defend territory, or coordinate movement. To marine life, sound is one of the most important tools for survival. Without it, many species would struggle to locate food or navigate through the dark waters of the deep sea. Scientists studying underwater acoustics continue to uncover new layers of this hidden communication system. Recent research suggests that some species may even use sound to map underwater landscapes, detecting subtle echoes returning from distant seafloor features. Others may recognize the acoustic signatures of specific habitats, allowing them to locate coral reefs or breeding grounds across large distances. The ocean soundscape is far more complex than humans once imagined. It is a dynamic network of signals, echoes, vibrations and calls travelling through water that stretches across the planet. For those who experience thalassophobia, the idea that unseen sounds move through dark water may intensify the feeling that the ocean hides unknown activity beneath the surface. But for scientists, these sounds represent something else entirely. They reveal that the deep ocean is not a silent void. It is a living environment filled with communication and movement, where creatures rely on sound to navigate a world where light rarely reaches. And as technology continues to improve, researchers are learning to listen more carefully to the hidden language of the sea, uncovering patterns of life that exist far beyond the limits of human vision. For as long as humans have travelled across the oceans, objects have been lost beneath the waves. Ships, cargo, tools and entire vessels have slowly descended into the depths, settling on the seafloor where currents move gently and sunlight rarely reaches. Over centuries, these sunken objects have formed a quiet collection of ruins scattered across the ocean floor. Some lie only a few meters below the surface, where divers can easily explore them. Others rest thousands of meters deep in complete darkness, where only specialized submersibles have ever visited them. The ocean holds an extraordinary number of these underwater relics, each representing a moment when human activity intersected with the immense power of the sea. For many people, the idea of shipwrecks beneath the ocean adds another layer to the strange feeling associated with deep water. The presence of human structures lying silently in the dark creates an image that can feel both fascinating and unsettling. Unlike natural underwater landscapes, shipwrecks represent something familiar that has been placed in an unfamiliar environment. A ship is designed to travel across the water, not rest beneath it. When such a structure appears on the ocean floor, the brain recognizes its shape immediately. Decks, railings, ladders, and hulls all carry the marks of human engineering. But the surrounding environment transforms the object into something almost alien. The ship no longer floats. It lies tilted or partially buried in sediment. Marine life grows across its surface. Rust slowly reshapes its structure over decades, and all of this happens in a world of dim light or total darkness. For someone experiencing thalassophobia, imagining these silent structures resting far below the surface can intensify the sense that the ocean hides forgotten places. But the presence of shipwrecks in the ocean is actually quite common. Throughout history, humans have used the sea for travel, trade, exploration, and warfare. Thousands of vessels have crossed oceans carrying goods and passengers between continents. Inevitably, some of those vessels encountered storms, navigational errors, mechanical failures, or conflicts that caused them to sink. Estimates suggest that more than 3 million shipwrecks may exist across the world's oceans. Most of these have never been located. Some lie close to shore where divers occasionally discover them by accident. Others remain hidden in deep water where the technology required to reach them is limited. Each wreck tells a story about the time in which it sailed. Ancient wooden ships carrying amphorae of wine or oil lie buried in Mediterranean sediments. Warships from past centuries rest quietly in coastal waters. Cargo vessels lost during global conflict still sit on the seabed where they sank decades ago. The ocean acts almost like a time capsule. In deep water, conditions can slow the process of decay. Low temperatures and limited oxygen reduce the activity of bacteria that normally break down organic materials. As a result, certain shipwrecks remain remarkably well preserved. One of the most famous examples is the Titanic. When the RMS Titanic sank in 1912 after striking an iceberg in the North Atlantic, the ship descended nearly 4,000 meters to the seafloor. For decades, its exact location remained unknown. It was not until 1985 that a deep-sea expedition finally located the wreck using remote cameras and sonar equipment. When the images first appeared on screens aboard the research vessel, scientists saw something remarkable. The bow of the ship stood upright on the seabed. its massive hull still recognisable despite decades spent beneath the ocean. Railings and windows remained visible. The ship's structure looked almost as if it had been placed gently onto the seafloor rather than falling through kilometres of water. The surrounding environment was dark and cold. Tiny particles of sediment drifted through the water like slow-falling snow. For the researchers observing those first images, the scene felt both historical and eerie. Here was a human structure designed to carry passengers across the ocean, now resting silently in one of the deepest parts of the Atlantic. The discovery of the Titanic revealed something important about deep ocean environments. They preserve objects in ways that are difficult to replicate on land. In shallow waters, shipwrecks often deteriorate quickly because waves, currents, and marine organisms gradually break them apart. But in deeper regions where currents move slowly and oxygen levels remain low, structures may remain intact for far longer periods. Still, even in deep water, time continues to reshape these underwater ruins. Metal surfaces slowly corrode as chemical reactions occur between seawater and the materials used to build a ship. Certain bacteria consume iron from steel hulls, forming structures that resemble rust-coloured icicles hanging from railings and decks. These formations, sometimes called rusticles, gradually weaken the ship's structure over time. Eventually, even the most massive vessels will collapse as the ocean slowly reclaims them. Yet during the years or centuries before that collapse occurs, shipwrecks often become artificial reefs supporting entire ecosystems. Fish gather around the structure, using it for shelter. Coral and sponges attach themselves to exposed surfaces. Crabs and other crustaceans explore the crevices of the wreck, searching for food. What began as a human-made object eventually becomes integrated into the surrounding marine environment. For divers exploring shallow wrecks, this transformation creates a fascinating mixture of history and biology. Swimming through the remains of a ship covered in coral and fish feels like visiting a place where two worlds overlap. Human engineering and marine life share the same space. In deeper waters, however, the atmosphere changes. Darkness surrounds the wreck. Visibility may be limited to the light beams of the submersible exploring the site. As the vehicle moves slowly through the water, its lights reveal sections of the ship emerging from the darkness. A railing appears, then a broken mast. Perhaps a cargo hold filled with objects that have not been touched in decades or centuries. For many observers, this slow emergence from darkness creates a powerful emotional effect. The human mind recognizes the shapes of familiar structures, but sees them placed in an environment that feels distant and isolated. This combination of familiarity and isolation can amplify the psychological response associated with deep water. Shipwrecks also create shadows that move with the subtle currents of the ocean. When a submersible's lights shine across the wreck, beams reflect off metal surfaces and drift through particles suspended in the water. The structure casts long shadows across the seafloor. As the vehicle moves, those shadows shift slowly, revealing new shapes and angles. For someone already sensitive to the unknown spaces of the ocean, these shifting forms can feel mysterious. The mind briefly wonders what lies beyond the edges of the light. Beyond the illuminated area, darkness returns immediately. The wreck disappears once again into the black water. Another aspect that contributes to the emotional impact of submerged ruins is the idea of abandonment. Buildings on land eventually decay when people stop maintaining them. Windows break, roofs collapse, plants grow through cracks in the walls. But underwater structures experience a different kind of abandonment. They remain intact, yet silent. A ship resting on the sea floor still resembles the vessel it once was, but no crew walks its decks. No passengers move through its corridors. Everything remains frozen in the moment when the vessel sank. For historians and archaeologists, this preservation provides valuable information about past events. Cargo items, tools, and personal belongings sometimes remain in place, allowing researchers to reconstruct the final moments of the ship's journey. But for someone imagining the scene in the darkness of the deep ocean, the stillness can feel haunting. A human-made environment exists far from sunlight, surrounded by creatures that have adapted to the deep sea. In that sense, the wreck becomes a quiet intersection between human history and the vast natural world of the ocean. Yet despite the mysterious atmosphere surrounding underwater ruins, most shipwrecks are not places of danger or horror. They are historical sites that provide insight into maritime history, trade routes, and technological development. They also support thriving marine ecosystems that grow across their surfaces. The ocean gradually transforms these wrecks into habitats where fish and invertebrates find shelter. Over time, coral colonies may grow across decks and hulls, turning the structure into a living reef. What once represented tragedy or loss eventually becomes part of the ocean's natural environment. For scientists and divers, exploring these sites often inspires curiosity rather than fear. Each wreck tells a story waiting to be understood. Each artifact reveals something about the people who travelled across the sea long ago. And each structure reminds us that the ocean is not only a place of natural mystery, but also a record of human history. Still, the thought of silent ships resting in the darkness far below the surface continues to capture the imagination. It reinforces the feeling that the ocean contains hidden places, forgotten objects, and stories that remain buried beneath layers of water and time. In the vast depths where sunlight never reaches, these submerged ruins wait quietly, surrounded by drifting particles and slow-moving creatures, while the ocean carries on above them without ever revealing what lies beneath. When a person enters the open ocean, something subtle happens to the way the mind interprets the world. It does not always happen immediately. At first, the environment may seem calm and even peaceful. The surface of the water stretches out toward the horizon, waves rise and fall in slow patterns, and the air carries the familiar scent of salt and wind. But as time passes, especially when land disappears from view, the brain begins to notice something unusual about the environment. There are no boundaries. On land, the human mind constantly uses landmarks to maintain orientation. Trees, buildings, mountains, and roads all provide reference points that help us understand where we are. Even when travelling through unfamiliar places, the brain quickly begins mapping the surroundings by identifying objects that remain fixed in the landscape. The open ocean removes most of those markers. When standing on the deck of a boat far from shore, the horizon becomes the only visible boundary. The sky stretches above, the water stretches below, and the line where they meet forms a nearly perfect circle around the observer. Everything beyond that circle remains unseen. This lack of visible landmarks affects the human brain in interesting ways. Psychologists who study environmental perception often describe this experience as spatial isolation. The mind recognizes that it is surrounded by a vast environment with very few points of reference. Without landmarks to anchor perception, the brain must rely on other signals to maintain orientation. One of those signals is movement. On land, the ground beneath our feet remains stable. When we walk, our bodies move across a surface that does not shift beneath us. This stability allows the brain to maintain a consistent sense of balance and direction. The ocean changes that relationship. A boat moves with the waves. The surface of the water rises and falls continuously. Even when the sea appears calm, small motions ripple across the surface, gently rocking anything floating above it. For most people, this motion feels manageable, but it still introduces a subtle difference in how the brain processes balance. The inner ear, which helps control our sense of equilibrium, constantly receives signals about the motion of the body. In a moving environment like the ocean, those signals may conflict slightly with what the eyes see. The horizon remains steady, but the body shifts with the waves. For some individuals, this mismatch between visual and physical signals can produce mild disorientation. Over longer periods, especially during extended time at sea, The brain must adapt to these changing conditions. Another factor influencing the mind in open water is the sensation of isolation. Humans evolved as highly social animals. For most of our history, survival depended on living within groups. Communities provided protection, shared resources, and social connection. Even in modern life, people rarely spend long periods completely alone in large open environments. The open ocean creates a setting where that social context may feel distant. When someone finds themselves far from land, surrounded only by water and sky, the brain may begin to interpret the environment as unusually empty. There are no buildings, roads, or signs of human activity stretching across the horizon. Just water moving quietly in every direction. For some people, this emptiness feels peaceful. Sailors often describe a sense of calm when travelling through open waters, where the distractions of daily life fade away and the rhythm of the sea becomes the dominant experience. But for others, the same environment can produce a feeling of vulnerability. Without visible landmarks or nearby people, the mind becomes aware of how large the surrounding space truly is. The ocean covers more than 70% of the Earth's surface. When standing in the middle of it, the nearest shoreline might lie hundreds of kilometres away. This awareness can trigger what psychologists call environmental exposure. Environmental exposure occurs when a person realises that they are present in a setting where shelter or assistance may not be immediately available. The brain begins evaluating possible risks. What would happen if something went wrong? How far away is help? Is there a safe place to go if conditions change? Even when these concerns remain in the background, they influence how the mind perceives the environment. Another aspect of open water that affects the brain involves visual simplicity. On land, the human visual system processes thousands of objects at once. Buildings, trees, vehicles, and people create a rich visual environment filled with details and patterns. The open ocean presents a much simpler scene: water, sky, and horizon. Occasionally a passing cloud or distant bird appears, but otherwise the visual field remains relatively empty. This simplicity can have interesting psychological effects. Some people find the lack of visual complexity relaxing. Meditation practices sometimes encourage individuals to focus on simple, repetitive environments precisely because they reduce mental distractions. Watching waves move across the surface of the ocean can produce a calming rhythm that slows the pace of thought. But when the brain expects more visual information and does not receive it, it may begin searching for patterns. Humans possess a strong tendency toward pattern recognition. We look for shapes in clouds, faces in shadows, and movement in distant landscapes. In environments with minimal visual detail, the brain sometimes begins interpreting small changes in the water's surface as potential objects or motion. A ripple may appear as something swimming beneath the water. A distant reflection might look like a shape rising from the surface. Most of the time, these interpretations quickly fade once the brain receives more information. But in environments where the surroundings remain uncertain, the mind may continue scanning for patterns. This heightened awareness connects closely with the experience of thalassophobia. When floating in open water, the brain understands that depth lies beneath the surface. Even if nothing unusual is visible, the knowledge that the ocean continues downward for hundreds or thousands of meters remains present in the background. The mind may begin imagining what exists in that hidden space. This process often becomes stronger when a person is physically in the water rather than observing from a boat or shoreline. Swimming removes the barrier between the body and the ocean. The swimmer becomes part of the environment rather than simply observing it. In that situation, the brain becomes more sensitive to changes in the surroundings. Temperature shifts, subtle currents, or distant movements may feel more significant. Some swimmers report that after floating in deep water for several minutes, they become more aware of the space beneath them. Even though nothing may be visible below, the mind begins imagining the depth extending downward. This awareness sometimes creates a sensation of vertigo similar to what people experience when looking down from a great height. The body remains supported by water, but the mind recognizes the enormous vertical distance below. Psychologists sometimes describe this sensation as aquatic vertigo. It occurs when the brain struggles to reconcile the feeling of floating with the knowledge of depth beneath the body. For individuals sensitive to this effect, simply looking down into deep water can produce a sudden feeling of unease. Another interesting element of the mind in open water involves time perception. When surrounded by familiar environments filled with activity, people often track time using external cues. Traffic patterns, conversations, and daily routines all signal the passing hours. At sea, these cues become less noticeable. The ocean surface moves slowly and consistently. The horizon remains unchanged. Even the sky may appear similar for long periods if weather conditions remain stable. Without clear external markers, the brain may experience time differently. Some sailors report that hours at sea can feel shorter than expected because the environment encourages a steady, rhythmic pace of attention. Others describe the opposite effect. The quiet simplicity of the ocean may cause time to feel stretched or elongated. Minutes pass slowly as the mind focuses on subtle changes in waves or distant clouds. This shift in time perception can enhance the feeling of isolation for some individuals. The environment becomes both vast and unchanging, but it is important to remember that the human brain is also remarkably adaptable. Many people who spend extended time at sea gradually adjust to the environment. Sailors, marine researchers, and divers often develop a comfortable relationship with open water after repeated exposure. The mind learns to interpret the ocean's patterns and movements more confidently. The horizon becomes familiar rather than intimidating. The rhythm of the waves becomes predictable rather than disorienting. In these cases, the sense of isolation transforms into something else, a feeling of connection with the vast natural environment surrounding the individual. Yet for people who experience thalassophobia, the psychological response may remain more intense. The open ocean removes many of the signals that normally reassure the brain. No ground beneath the feet, no buildings or roads marking distance, no immediate boundaries defining the environment. Instead, there is only water stretching outward and downward beyond the limits of human vision. For the human mind, this combination of isolation and vastness can create a powerful emotional response. But it also reveals something important about our relationship with the natural world. Humans evolved in environments where the landscape provided clear structure and familiar patterns. The open ocean offers something very different, a place where space feels endless, where landmarks disappear, and where the mind must navigate an environment far larger than the landscapes our species originally called home. And it is within that vast open space that the human brain begins to confront both its curiosity and its caution when floating above the deep water below. For most of human history, the deep ocean remained completely out of reach. People could sail across its surface, fish in its upper waters, and watch the waves roll across the horizon, but the depths beneath remained hidden. Even the most experienced sailors had no way to see what existed far below their ships. The ocean was simply too deep. Early explorers understood that the sea contained immense depth, but they could only estimate how far down it extended. Sailors occasionally lowered weighted ropes into the water to measure depth, a method known as sounding. The rope would sink until it touched the seafloor, allowing them to determine how deep the water was in that particular location. But this method had limitations. If the water was too deep, the rope might not reach the bottom at all. In many parts of the open ocean, sailors simply had to accept that the seafloor lay far beyond their ability to measure. For centuries, this uncertainty allowed imagination to fill the gaps. Some people believed the ocean floor contained enormous underwater mountains or hidden valleys where strange creatures lived. Others wondered whether entire landscapes existed beneath the waves that humans might never see. It was not until the 19th century that scientists began studying the ocean in a systematic way. One of the first major scientific expeditions dedicated to ocean research was the voyage of the HMS Challenger in the 1870s. This British research vessel travelled across the world's oceans collecting samples of seawater, marine life, and seafloor sediment. The scientists aboard the Challenger conducted hundreds of depth measurements and dredged the seafloor using nets designed to collect organisms living in deep water. When the expedition returned with its findings, it transformed scientific understanding of the ocean. Before the Challenger voyage, some scientists believed that life could not exist in the deepest parts of the sea because of the extreme pressure and darkness. But the expedition recovered numerous animals from deep water, proving that life thrived even at great depths. These discoveries sparked curiosity about what else might exist in the unexplored regions of the ocean. Still, observing those environments directly remained impossible. To see the deep sea with human eyes, scientists would need to descend into the water themselves. The challenge was enormous. Pressure increases rapidly with depth. At 1,000 meters below the surface, the pressure becomes 100 times greater than the pressure experienced at sea level. At depths of several thousand meters, the force becomes so great that it can crush ordinary materials instantly. Human bodies cannot survive such conditions without protection. Engineers, therefore, began designing special vehicles capable of withstanding the immense pressure of the deep ocean. One of the earliest attempts was the bathysphere, a steel sphere built in the early 20th century. The bathysphere was designed to carry two people into the ocean while suspended from a cable attached to a ship above. The sphere had thick steel walls and small windows made from strong quartz, allowing observers to look out into the surrounding water. In 1934, American explorer William Beebe and engineer Otis Barton used the bathysphere to descend nearly 1,000 meters below the surface near Bermuda. For the first time in human history, people observed the deep ocean environment directly. Beebe later described the experience as both beautiful and unsettling. As the bathysphere descended, sunlight faded quickly. The water outside the window grew darker until only the beam of their spotlight revealed shapes moving in the distance. Strange fish with glowing organs drifted through the darkness. Creatures that had never been seen alive by humans appeared briefly in the light before vanishing again into the black water. The bathysphere allowed scientists to glimpse the deep ocean, but it had limitations. Because it was attached to a cable, the vehicle could not move freely. It simply descended and ascended along the line while observers watched through the small window. Engineers soon began developing more advanced vehicles capable of independent movement. These vehicles became known as bathyscaphs. Unlike the bathysphere, a bathyscaph was designed to travel freely through deep water, using ballast tanks and buoyant materials. One of the most famous bathyscaphs was the Trieste. Built by Swiss engineer Auguste Piccard and later used by the United States Navy, the Trieste made history in 1960 when it carried Piccard's son Jacques Piccard and US Navy Lieutenant Don Walsh to the deepest known point in the ocean. Their destination was the Challenger Deep in the Mariana Trench. The Mariana Trench lies in the western Pacific Ocean and contains the deepest location ever measured on Earth. The depth of Challenger Deep is nearly 11,000 meters below the surface. Reaching that depth required nearly 5 hours of descent. Inside the Trieste, Piccard and Walsh sat in a small pressure-resistant sphere as the vehicle slowly sank into the darkness. Sunlight faded quickly during the descent. Within minutes, the ocean outside the window became dark. As the bathyscaph continued downward, the pressure outside increased to levels that would crush most objects instantly. Yet the Trieste's thick steel sphere protected the crew inside. Finally, after nearly 5 hours, the vehicle reached the seafloor. When Piccard looked out of the window, he saw a flat landscape of pale sediment stretching across the bottom of the trench. Contrary to earlier expectations, the environment was not barren. A small fish-like creature drifted past the window, demonstrating once again that life existed even at the deepest parts of the ocean. The descent of the Trieste marked a major milestone in human exploration. It proved that technology could carry people to the deepest parts of the sea. But manned deep-sea exploration remained rare because of the cost and difficulty involved. Instead, scientists increasingly relied on robotic vehicles to explore the ocean depths. These machines, known as remotely operated vehicles or ROVs, are connected to research ships by long cables that transmit power and data. ROVs carry cameras, lights, and robotic arms that allow scientists to observe marine life and collect samples from the seafloor. More recently, autonomous underwater vehicles have expanded exploration even further. These robots operate without cables, navigating the ocean independently while mapping the seafloor and recording environmental data. With these technologies, scientists have discovered underwater mountains taller than some of the world's highest peaks. They have found volcanic vents where superheated water pours from cracks in the seafloor, supporting ecosystems filled with unique organisms that survive without sunlight. They have observed deep sea creatures drifting through darkness thousands of meters below the surface. Each expedition reveals something new about the ocean. Yet despite these advances, the deep sea remains one of the least explored environments on Earth. Scientists estimate that more than 80% of the ocean floor has never been directly observed in detail. Many underwater regions remain completely unmapped. Entire ecosystems may exist in places that humans have never visited. This vast unknown contributes to the emotional reaction many people feel when thinking about the deep ocean. Even with modern technology, the ocean's depths remain mysterious. For individuals who experience thalassophobia, the idea of descending into such an environment can feel intimidating. Imagining a small submersible, surrounded by kilometers of dark water, may amplify the sense of isolation and uncertainty associated with deep environments. But for scientists and explorers, these same conditions inspire curiosity. The deep ocean represents one of the last great frontiers on Earth. Just as early explorers once crossed unknown continents and mapped distant lands, modern researchers descend into the ocean searching for answers about the planet's largest habitat. Each journey into the depths expands human understanding of life, geology, and the processes that shape our world. The ocean floor contains clues about Earth's climate history, underwater volcanoes that influence global ecosystems, and organisms that have evolved under extreme conditions. By studying these environments, scientists hope to learn not only about the ocean itself, but also about the limits of life on our planet. In the end, deep-sea exploration reveals something remarkable about the human spirit. Despite the fear and uncertainty that vast unknown spaces can produce, humans continue searching for knowledge. They build machines capable of surviving crushing pressure. They descend into darkness where sunlight has never reached. And with each descent, they bring back images and discoveries that remind us how much of our own planet remains unexplored beneath the surface of the sea. If someone were able to travel across the Pacific Ocean and stop at a very specific location east of the Philippines, they would be floating above one of the most extreme places on Earth. From the surface, there would be nothing unusual to see. The water would stretch out in every direction just like any other part of the open ocean. Waves would rise and fall slowly, the sky would meet the horizon in a smooth line, and seabirds might occasionally pass overhead. But directly beneath that calm surface lies a geological feature so deep that it challenges how the human mind understands vertical space. This place is known as the Mariana Trench. The Mariana Trench is the deepest known part of the world's oceans. It stretches for roughly 2,500 kilometers across the western Pacific Ocean, forming a long curved depression in the seafloor. At its deepest point, called Challenger Deep, the trench reaches a depth of nearly 11,000 meters. To put that into perspective, imagine taking Mount Everest, the tallest mountain on land, and placing it inside the trench. the peak of Everest would still remain more than 2 kilometers below the ocean's surface. That is the scale of the Mariana Trench. For centuries, humans had no idea that such extreme depths existed. Early sailors measuring ocean depth with weighted ropes occasionally recorded very large numbers, but these measurements were often incomplete or inaccurate. The ropes simply could not reach the bottom in some places, leaving large areas of the ocean unexplored. The first strong evidence of the trench's enormous depth appeared during scientific expeditions in the late 19th century. Researchers using more advanced sounding techniques discovered that parts of the Pacific Ocean contained depressions far deeper than previously imagined. Later measurements using sonar technology revealed the shape of the trench more clearly. Sonar works by sending sound waves downward into the water. When those waves hit the sea floor, they bounce back to the surface. By measuring the time it takes for the sound to return, scientists can calculate the depth of the water below. Using sonar mapping, researchers discovered that the Mariana Trench was not simply a deep hole but a long valley carved into the ocean floor. This valley formed through a process known as subduction. The Earth's outer shell is divided into large sections called tectonic plates. These plates slowly move across the surface of the planet over millions of years. In some regions, one plate slides beneath another, in a process that pushes sections of the seafloor downward into the Earth's mantle. The Mariana Trench formed where the Pacific Plate moves beneath the smaller Mariana Plate. As the Pacific Plate sinks downward, it pulls the seafloor along with it, creating a deep trench that continues to grow and change over geological time. The environment inside the trench is unlike almost anywhere else on Earth. At depths approaching 11,000 meters, the pressure becomes almost unimaginable. Every 10 meters of water adds another layer of pressure. By the time a depth of 1,000 meters is reached, the pressure has already increased to roughly 100 times the pressure at sea level. At Challenger Deep, the pressure reaches more than 1,000 times the pressure experienced on land. To understand how powerful this force is, imagine placing the weight of several fully loaded passenger jets onto a surface no larger than a human hand. That is the kind of pressure that exists at the bottom of the trench. Human bodies cannot survive such conditions without protection. If a person were somehow exposed to that pressure without specialized equipment, the water would compress their body almost instantly. This is why exploring the Mariana Trench requires extremely strong vehicles designed specifically to withstand immense force. One of the first successful descents to the bottom of the trench occurred in 1960. Jacques Piccard and Don Walsh travelled to Challenger Deep aboard the bathyscaphe Trieste, a deep-sea submersible designed with a thick steel pressure sphere. The journey to the bottom took nearly 5 hours. As the Trieste descended, sunlight faded quickly. Within minutes, the ocean outside the small viewing window turned completely dark. The only light came from the submersible's powerful lamps. After hours of descent, the Trieste finally touched the seafloor. Piccard later described seeing a flat landscape of pale sediment stretching across the bottom. The water around the vehicle was stirred up by its landing, creating a cloud of particles drifting through the beam of light. Despite the crushing pressure and complete darkness, the explorers observed signs of life. Small shrimp-like creatures moved across the sediment. Later expeditions confirmed that the trench supports a variety of organisms adapted to extreme conditions. For decades after the Trieste mission, no human returned to the deepest part of the Mariana Trench. The difficulty and expense of such journeys meant that most deep-sea exploration focused on robotic vehicles instead. But in 2012, filmmaker and explorer James Cameron made another historic descent. Using a specially designed submersible called the Deep Sea Challenger, Cameron travelled alone to Challenger Deep. The submersible was built to withstand the enormous pressure at the bottom of the trench while carrying cameras and scientific instruments. During the descent, Cameron observed the gradual transition from sunlight to darkness. By the time the vehicle reached its final depth, the environment outside the window was completely black. The only visible landscape came from the lights attached to the submersible. Cameron described the seafloor as a quiet, alien environment where fine sediment covered the ground like dust. The area appeared almost lifeless at first glance, but closer inspection revealed small organisms living within the mud. Since that expedition, robotic vehicles have continued exploring the Mariana Trench. These missions have revealed surprising discoveries. Researchers have found microorganisms capable of surviving extreme pressure. They have observed amphipods, small crustaceans that inhabit the deep ocean floor. They have also discovered that pollution from the surface world can reach even the deepest parts of the ocean. Plastic debris and chemical contaminants have been detected in samples collected from the trench, demonstrating how interconnected Earth's ecosystems truly are. The trench also contains geological features such as underwater landslides and ridges formed by shifting tectonic plates. These formations remind scientists that the seafloor remains an active environment shaped by forces operating deep within the Earth. For people who experience thalassophobia, the idea of the Mariana Trench can feel particularly intense. Looking out over the ocean's surface already creates the awareness that depth exists below. But learning that some regions descend nearly 11 kilometers downward transforms that awareness into something even more dramatic. The human mind struggles to visualize such depth. Even standing on the edge of the tallest mountain would not provide a vertical drop approaching the depth of the trench. Yet beneath certain parts of the Pacific Ocean, that space exists quietly beneath the waves. From the surface, nothing about the water reveals the presence of the trench. Ships pass overhead without noticing anything unusual. Storms move across the ocean above while the deep valley remains untouched below. This contrast between the calm surface and the immense depth beneath contributes to the mysterious reputation of the trench. It is a place where sunlight has never reached, where pressure exceeds nearly every other environment on Earth, and where life continues to survive in conditions once thought impossible. Yet despite its extreme nature, the Mariana Trench is not a place of monsters or hidden threats waiting in the darkness. It is a geological feature shaped by the slow movement of Earth's tectonic plates. It is a habitat where specialized organisms live quietly in the sediment, and it is a reminder that our planet contains landscapes as vast and mysterious beneath the ocean as those found on land. The trench represents the deepest known point of Earth's oceans, but it also represents something else, a frontier that humans have only begun to explore. Even today, only a handful of expeditions have reached its bottom. The vast majority of the trench remains unseen by human eyes, and somewhere in that immense underwater valley, thousands of meters below the surface, the silent seafloor continues to stretch into darkness, while the ocean above moves on as if nothing extraordinary lies beneath it. If someone were able to descend slowly through the ocean at night, passing through the surface waters and drifting deeper into the dark layers below, something remarkable would begin to appear. At first, there would be almost nothing to see. The water would grow darker as sunlight fades away, and the surroundings might seem empty. Then, suddenly, a small flash of light might appear, not from a flashlight or any human device, but from a living creature moving through the water. Another faint glow might appear nearby, then another. In the darkness of the deep ocean, living organisms often produce their own light. This phenomenon is known as bioluminescence, and it is one of the most fascinating biological processes found in marine environments. To people unfamiliar with the deep ocean, the idea of glowing animals drifting through black water may sound unusual or even unsettling. Yet in the depths of the sea, bioluminescence is not rare at all. In fact, scientists estimate that a majority of organisms living in the deep ocean are capable of producing light. The reason this ability evolved becomes easier to understand when considering the environment in which these animals live. As depth increases in the ocean, sunlight fades quickly. Beyond about 1,000 meters below the surface, natural sunlight disappears completely. The water becomes permanently dark. In such an environment, animals cannot rely on vision in the same way creatures on land do. There is no sunlight illuminating the surroundings, and shapes are difficult to distinguish even at close range. Producing light becomes a useful solution to this challenge. Bioluminescent organisms generate light through a chemical reaction inside their bodies. The reaction typically involves a molecule called luciferin and an enzyme known as luciferase. When these two components interact in the presence of oxygen, they release energy in the form of visible light. Unlike a traditional light bulb, this reaction produces very little heat. The light appears cool and efficient, allowing organisms to generate illumination without wasting energy. The colours produced by bioluminescence vary, depending on the species. Most deep-sea organisms emit blue or green light because those wavelengths travel farther through seawater than other colours. Red light, for example, disappears quickly in the ocean because water absorbs it more easily. Blue light, however, can travel longer distances before fading, making it the most practical colour for communication or signalling underwater. Different species use bioluminescence for different purposes. One common use is attracting prey. Some deep-sea fish possess glowing lures attached to their bodies. The anglerfish is a well-known example. This fish carries a small glowing appendage extending from its head. In the darkness of the deep ocean, the lure shines like a tiny beacon. Smaller fish or crustaceans may be drawn toward the light out of curiosity. As the prey approaches, the anglerfish opens its large mouth and captures it. In this way, bioluminescence becomes a powerful hunting tool. Other animals use light for defense. Certain squid and shrimp can release glowing clouds of bioluminescent particles into the water when threatened. These glowing bursts act almost like underwater smoke screens. The sudden flash of light distracts predators, giving the smaller animal time to escape into the darkness. Some species even produce flashes of light when touched or disturbed. These flashes may startle predators or attract the attention of larger animals that might threaten the attacker. In the darkness of the deep ocean, even a brief flash can travel far through the water. Communication represents another important use of bioluminescence. Certain marine animals produce patterns of light that help them identify members of their own species. These patterns may appear as rows of glowing dots along the body, or pulses of light emitted in rhythmic sequences. In environments where visual signals from sunlight are absent, these glowing displays help animals locate potential mates or maintain contact with others of their kind. Some fish use light to disguise themselves as well. One technique known as counter-illumination involves producing faint light along the underside of the body. This light matches the faint glow filtering down from the surface far above. When a predator looks upward, the fish's silhouette blends with the surrounding brightness, making it harder to detect. This adaptation helps animals remain hidden in a world where darkness and light interact in subtle ways. Bioluminescence is not limited to large animals. Many microscopic organisms also produce light. One of the most common examples occurs near the ocean's surface at night. Certain plankton species emit brief flashes of blue light when disturbed by movement in the water. If waves crash along a shoreline or a swimmer moves through the water, these tiny organisms may produce thousands of small flashes at once. The result can look like glowing sparkles spreading through the water. In some coastal regions, entire beaches appear to glow at night because of these plankton. When waves break against the shore, the water lights up with brilliant blue flashes. For people witnessing this phenomenon for the first time, the sight can be both beautiful and surprising. The water appears alive with light. Even though bioluminescence is most common in deep water, these surface displays remind us that the ocean contains living light at many depths. Scientists continue studying bioluminescence to understand its many functions. Some species produce steady glows, while others create rapid flashes. Some animals generate light continuously, while others activate their glow only under specific conditions. Researchers believe there may still be many forms of bioluminescence that have not yet been discovered. Because the deep ocean remains largely unexplored, new glowing species are occasionally revealed during deep-sea expeditions. Robotic vehicles descending into the darkness sometimes capture footage of creatures flashing or glowing in patterns that scientists have never observed before. These discoveries suggest that the ocean's hidden light displays may be far more complex than previously imagined. For people who experience thalassophobia, the idea of glowing creatures moving through dark water may feel unsettling at first. In movies or stories, glowing eyes or lights in darkness are often associated with danger or mystery, but in reality, bioluminescence represents a practical survival tool developed by marine life over millions of years. The deep ocean environment lacks sunlight, so animals create their own sources of illumination. In many ways, this ability makes the deep sea more active and vibrant than it might otherwise appear. Without bioluminescence, the abyssal ocean would be almost completely dark. With it, the environment becomes filled with flashes, pulses, and gentle glows drifting through the water. Researchers studying these glowing organisms have even begun exploring ways bioluminescence might benefit human technology. Certain bioluminescent proteins have been used in medical research to track cellular activity. By attaching glowing molecules to specific biological processes, scientists can observe how cells behave under different conditions. This technique has helped advance research in areas such as disease detection and genetic studies. In this way, the natural light produced by deep sea organisms may eventually contribute to advances in human medicine. Yet despite these scientific applications, the sight of bioluminescent life remains one of the most extraordinary experiences the ocean can offer. Imagine descending slowly into the deep sea inside a submersible. The lights of the vehicle switch off for a moment. At first there is nothing but darkness. Then small sparks begin to appear outside the window. Tiny points of blue light drift upward through the water like distant stars. Some pulse briefly and fade. Others glide slowly through the darkness before disappearing. For the creatures living in the deep ocean, these glowing signals form part of everyday life. For humans observing from the surface, they reveal a hidden world where living organisms illuminate their surroundings in the absence of sunlight. The ocean may seem dark and mysterious from above, but deep below the surface life continues to shine in quiet flashes of blue and green light drifting through the endless night of the sea. If a person were able to descend slowly beneath the ocean surface, one of the most dramatic changes would not be visible at all. It would not involve darkness, temperature, or strange creatures drifting through the water. Instead, it would be something invisible yet immensely powerful. Pressure. Every meter of water above a person adds weight. Water may seem light when you scoop it into your hands or watch waves roll across the shore, but when it collects in enormous volumes, the force becomes extraordinary. The ocean is not just wide, it is deep, and that depth creates an environment where pressure increases rapidly the farther one travels downward. At sea level on land, the human body already experiences pressure from the atmosphere. Air pressing down from above creates a force that surrounds us constantly, although we rarely notice it. This pressure equals about 1 atmosphere, which scientists measure as roughly 1 kilogram of force, pressing on each square centimetre of surface. Our bodies have evolved to live comfortably under that pressure, but water adds much more weight than air. For every 10 metres a person descends underwater, the pressure increases by approximately 1 additional atmosphere. At 20 metres below the surface, the pressure becomes about 3 times greater than the pressure experienced on land. At 100 metres, it rises to roughly 11 times greater. These numbers continue increasing with depth. By the time a depth of 1,000 metres is reached, the pressure becomes about 100 times stronger than the atmospheric pressure at sea level. In the deepest parts of the ocean, such as the Mariana Trench, the pressure reaches levels exceeding 1,000 atmospheres. That means the water surrounding an object at those depths pushes inward with more than 1,000 kilograms of force on every square centimetre of surface area. It is difficult for the human mind to visualize such force. Imagine stacking dozens of large trucks on top of a small metal plate. The combined weight pressing downward would begin to approach the kind of pressure experienced at the bottom of the deepest ocean trenches. Yet in the abyss, that pressure surrounds objects from every direction. It pushes inward constantly. Human bodies cannot withstand such conditions without protection. If a person attempted to descend to extreme depths without specialized equipment, the pressure would compress the airspaces inside the body almost immediately. The lungs would collapse, and other tissues would be severely damaged. For this reason, deep ocean exploration requires specially designed vehicles capable of protecting humans from the crushing weight of the water. Submersibles used for deep sea exploration are built with extremely strong materials such as thick steel or titanium. These vehicles often include a spherical compartment where the crew sits during the descent. The spherical shape distributes pressure evenly across the structure, helping prevent collapse under the immense force of the surrounding water. Even with these precautions, engineering such vehicles is extremely challenging. Every window, hatch, and seam must be carefully designed to resist the crushing pressure outside. In many cases, the viewing windows used in deep-sea submersibles are surprisingly small. This is because larger openings would weaken the structure and increase the risk of failure. For people who experience thalassophobia, the idea of descending into the deep ocean, while surrounded by kilometers of water, can feel particularly intense. Imagining a small vehicle suspended in darkness while enormous pressure presses against its walls may amplify the sense of vulnerability associated with deep water. Yet despite these challenges, life in the deep ocean has adapted to these conditions in remarkable ways. Many organisms living in the abyss thrive under pressures that would instantly destroy most surface life. These creatures do not experience pressure the same way humans do. Their bodies contain very little air, which means there are no air-filled spaces that can collapse under pressure. Instead, their tissues are filled with fluids that match the pressure of the surrounding water. This allows the pressure inside their bodies to balance with the pressure outside. As a result, they are not crushed by the environment. Certain deep-sea organisms also possess specialized proteins that help their cells function under high pressure. These proteins remain stable even when compressed by the surrounding water. Scientists studying these adaptations have discovered that pressure can alter how biological molecules behave. In surface environments, enzymes and cellular structures operate under relatively mild pressure conditions. In the deep ocean, however, organisms must maintain these processes under extreme compression. Evolution has produced solutions that allow deep sea life to survive, where most other organisms could not. Fish living in deep water often have soft, flexible bodies that resist damage from pressure changes. Some species lack rigid bones entirely, relying instead on cartilage or gelatinous tissues. This flexibility allows their bodies to absorb pressure without structural failure. Crustaceans and other invertebrates have also adapted to life under immense pressure. Their shells and exoskeletons contain structural features that help distribute force evenly across their bodies. These adaptations prevent the pressure from concentrating in one area where it might cause damage. Even microorganisms living in the deep ocean show remarkable tolerance for pressure. Certain bacteria and archaea thrive at depths where the pressure exceeds hundreds of atmospheres. Scientists refer to these organisms as piezophiles, meaning pressure-loving organisms. They have evolved cellular systems specifically designed to operate under extreme compression. Studying these microorganisms has expanded scientific understanding of the limits of life on Earth. Researchers now believe that life may be able to survive in high-pressure environments beyond our planet, such as beneath the icy surfaces of certain moons in the outer solar system. But pressure does more than shape the biology of deep-sea creatures. It also influences the physical landscape of the ocean floor. Under extreme pressure, sediments behave differently than they would on land. Particles settle slowly through the water column and accumulate across the seabed. Because currents move gently at great depths, these sediments may remain undisturbed for long periods. The result is vast plains of fine mud covering large areas of the ocean floor. Occasionally, underwater landslides occur when sections of sediment shift suddenly under the weight of the material above. These movements can send clouds of particles drifting through the water for hours or days. The pressure at these depths also affects how gases behave. Air bubbles released at the surface expand as they rise because the surrounding pressure decreases. In the deep ocean, the opposite occurs. Gases become compressed and sometimes dissolve into the surrounding water. Certain chemical compounds remain stable under high pressure but break apart when brought to the surface. This means that organisms and materials recovered from deep-sea environments must be handled carefully. Rapid pressure changes during ascent can damage or destroy delicate biological structures. Another effect of pressure involves sound. Because water is compressed under high pressure, sound waves travel slightly faster in deeper regions of the ocean. This allows acoustic signals produced by marine animals to travel long distances through the deep sea. For whales and other species that rely on sound for communication, these acoustic properties help them maintain contact across vast areas of the ocean. The pressure of the abyss therefore shapes nearly every aspect of the deep-sea environment. It influences how animals evolve, how landscapes form, and how physical processes operate beneath the surface. From the perspective of a human observer, the idea of such immense force pressing against the ocean floor may seem intimidating. The mind naturally imagines what it would feel like to descend into such an environment. Yet for the organisms living there, the pressure is simply part of their natural world. They have evolved over millions of years to thrive under conditions that appear extreme from the human perspective. And while the abyss may seem like a world capable of crushing everything, it is also a place where life has found remarkable ways to endure. Far below the surface, beneath kilometers of water and darkness, creatures continue moving slowly through a landscape shaped by pressure that never relents, quietly surviving in one of the most powerful environments on the planet. When people look at a map of the world, the continents usually draw most of the attention. Large shapes of land fill the centre of the map, marked with borders, cities, roads, and mountains. Oceans often appear as wide blue spaces surrounding those landmasses, sometimes labelled with their names, but otherwise left mostly empty. At a glance, it can give the impression that the oceans are simple, uniform areas of water that connect the continents together. But that impression is far from accurate. Beneath the surface of those blue regions lies a landscape more complex than many people realise. The ocean floor contains mountain ranges longer than any on land. Vast plains stretching for thousands of kilometres, deep trenches descending farther than the tallest mountains rise, and volcanic systems that continuously reshape the planet's crust. Yet despite the importance of these underwater landscapes, much of the ocean remains largely unexplored. In fact, scientists estimate that more than 80% of the ocean floor has not been mapped in detail. To understand how surprising that is, it helps to compare ocean exploration with exploration on land. Humans have walked across nearly every continent. Satellites orbiting the Earth have photographed deserts, forests, and mountain ranges in remarkable detail. Remote sensing technologies allow scientists to observe the surface of distant planets such as Mars with greater resolution than many parts of our own oceans. But the ocean presents unique challenges that make exploration difficult. The most obvious challenge is depth. Unlike landscapes on land, the ocean floor lies beneath a massive layer of water. In many regions, that water extends several kilometres above the seabed. The average depth of the world's oceans is about 3,700 metres. This means that even the most advanced exploration equipment must travel long distances through water before reaching the seafloor. Water also blocks many types of signals that scientists use to study the environment. Satellite imaging works well for mapping land surfaces because light and radio signals can pass through the atmosphere and reflect off the ground. But water absorbs light quickly, preventing satellites from seeing the ocean floor directly. To map underwater terrain, scientists must rely on sonar systems attached to ships or underwater vehicles. Sonar works by sending sound waves down into the water. When those waves hit the seafloor, they bounce back toward the source. By measuring how long the sound takes to return, researchers can estimate the depth and shape of the ocean floor. This method works well, but it requires ships to travel across the ocean slowly while scanning the seafloor below. Considering the enormous size of the oceans, mapping them completely takes a tremendous amount of time and resources. The world's oceans cover more than 360 million square kilometres. Even with modern technology, surveying every section of that vast area is a long-term challenge. Another obstacle involves pressure. As depth increases, the pressure exerted by the surrounding water becomes immense. This pressure can damage equipment not specifically designed for deep-sea conditions. Submersibles and remotely operated vehicles used for exploration must be carefully engineered to survive in environments where pressure reaches hundreds or even thousands of atmospheres. Building and operating such machines is expensive, which limits how frequently they can be deployed. As a result, many parts of the ocean remain unexplored simply because reaching them requires significant effort. The deep ocean also lacks the accessibility of environments on land. Scientists can travel to forests, deserts, and mountains relatively easily. They can set up research stations and remain in place for extended periods. But studying the deep ocean often requires ships, specialized crews, and equipment capable of operating thousands of meters below the surface. Each expedition must be carefully planned and funded. Because of these challenges, only a small portion of the ocean floor has been directly observed by human eyes. Most of what scientists know about deep-sea environments comes from sonar data, samples collected from the seabed, and footage captured by robotic vehicles. Despite these limitations, every exploration mission tends to produce new discoveries. Researchers frequently encounter geological formations that had never been documented before. Underwater mountains called seamounts rise from the ocean floor in many regions. Some of these mountains are taller than the tallest peaks on land, yet they remain completely hidden beneath the sea. Hydrothermal vents form along underwater volcanic ridges, where superheated water rich in minerals pours from cracks in the seafloor. These vents support ecosystems filled with unusual organisms that survive without sunlight, relying instead on chemical energy produced by the vent fluids. Scientists have discovered giant tube worms, unusual crabs, and bacteria that thrive in these extreme environments. Each of these ecosystems was unknown before deep-sea exploration technology allowed researchers to observe them directly. The ocean's vastness also means that new species are discovered regularly. Marine biologists estimate that millions of species may exist in the ocean, many of which have not yet been described. Every year, scientists identify new fish, crustaceans, jellyfish, and microscopic organisms living in various ocean habitats. Some species inhabit coral reefs near the surface, others live in the deep sea where sunlight never reaches. In many cases, these organisms display adaptations unlike anything seen in land animals. Bioluminescent structures, flexible bodies designed to withstand pressure, and specialized feeding mechanisms appear frequently in deep-sea species. Because so much of the ocean remains unexplored, researchers believe that many more unusual organisms are waiting to be discovered. This sense of mystery contributes strongly to the psychological response people feel when thinking about the deep ocean. When the human mind encounters an environment that is both vast and largely unknown, imagination naturally begins to fill in the gaps. The ocean becomes a place where unseen landscapes and undiscovered creatures might exist. For individuals experiencing thalassophobia, this awareness can amplify feelings of unease. Looking out across the ocean surface, a person may realize that beneath the waves lies an enormous environment that humans have barely explored. The water may appear calm and empty from above, yet thousands of meters below, unknown ecosystems may stretch across the seafloor. This combination of visible simplicity and hidden complexity makes the ocean unique among Earth's environments. On land, the landscape usually reveals its structure clearly. Mountains rise above the ground. Rivers carve visible paths across valleys. Forests spread across hillsides. In the ocean, most of these features remain hidden beneath layers of water. Even the largest underwater mountains may leave no visible trace at the surface. Ships can travel directly above them without noticing their presence. Another interesting aspect of ocean exploration involves the rate at which new discoveries occur. Each improvement in technology allows scientists to observe deeper regions with greater clarity. High-resolution sonar mapping continues revealing previously unknown seafloor features. Advanced robotic vehicles equipped with cameras capture footage of organisms that had never been seen before. As exploration continues, scientists expect the number of discoveries to grow. The ocean represents one of the last great frontiers on our planet. Just as early explorers once travelled across unknown continents, modern researchers venture into the deep sea searching for information about Earth's largest habitat. These discoveries do more than satisfy curiosity. Understanding the ocean helps scientists study climate systems, marine ecosystems, and geological processes that influence the entire planet. Ocean currents regulate global temperatures. Marine organisms play a role in the carbon cycle. Underwater volcanic activity shapes the structure of Earth's crust. All of these processes operate within the vast underwater world that remains only partially understood. For many people, the idea that such a large portion of our planet remains unexplored is both exciting and humbling. It reminds us that even in an age of satellites and advanced technology, the Earth still contains regions where mysteries remain hidden. Looking across the ocean surface, it is easy to forget that the water below covers landscapes more extensive than the continents themselves. Mountains, valleys, and plains stretch silently beneath the waves. Entire ecosystems thrive in darkness where humans have rarely ventured. The ocean's unmapped vastness remains a reminder that the planet we inhabit still holds countless discoveries waiting beneath the surface. Not everyone feels uneasy when thinking about the deep ocean. In fact, for some people, the vastness of the sea produces the opposite reaction. Instead of fear, they experience fascination. Instead of discomfort, they feel curiosity. The same environment that makes one person anxious may inspire another to explore, study, or simply admire the enormous world beneath the waves. This contrast reveals something interesting about how the human mind interprets unfamiliar environments. Fear is one possible response to the unknown, but it is not the only one. The brain can also respond with interest, wonder, and a desire to understand. Many of the scientists and explorers who dedicate their careers to studying the ocean began with a sense of curiosity about what lies beneath the surface. As children, they might have visited a beach, watched waves rolling across the shoreline, and wondered what existed beyond the visible water. That curiosity sometimes grows stronger over time. The ocean becomes less of a mystery to avoid and more of a puzzle waiting to be explored. Part of this difference in response involves familiarity. When people spend more time around the ocean, the environment gradually becomes easier for the brain to interpret. The sounds of waves, the motion of water, and the changing colours of the sea start to feel normal rather than uncertain. Someone who swims regularly in coastal waters may become comfortable with the sensation of floating above deeper areas. A diver who trains carefully and gains experience underwater often develops confidence in navigating the environment. Knowledge also plays a role. When a person learns about marine ecosystems, ocean currents, and the behaviour of sea creatures, the unknown becomes less intimidating. Understanding why certain fish glow in the dark or why water changes colour at different depths transforms mystery into information. Instead of imagining something frightening in the darkness, the mind begins recognising patterns shaped by biology and physics. Marine biologists, for example, often describe the deep ocean with excitement rather than fear. For them, the darkness of the abyss represents a place filled with scientific discoveries. Every expedition into deep water offers the possibility of observing species that have never been documented before. Some researchers spend months at sea studying ecosystems thousands of meters below the surface. For these scientists, the deep ocean is not an environment to avoid, but a place where curiosity leads to new knowledge. Divers provide another example of how familiarity can change perception. Learning to dive requires careful training. Divers practice breathing through specialized equipment, managing buoyancy, and navigating underwater landscapes safely. At first, descending beneath the surface may feel unusual. The sensation of breathing through a regulator and floating weightlessly in the water requires the brain to adjust to new conditions. But as divers gain experience, many begin to enjoy the underwater environment. They notice details that remain invisible from the surface. Schools of fish move through coral reefs. Sunlight filters through the water in shimmering patterns. Marine plants sway slowly in gentle currents. For some divers, deeper environments offer even more fascination. Descending along a reef wall where the seabed drops away into open blue water may initially feel intimidating, but experienced divers often describe this moment as one of the most memorable parts of a dive. Looking out into the vast blue space reveals how enormous the ocean truly is. Instead of triggering fear, this realization can produce a feeling of awe. Awe is an important psychological response connected to environments that appear vast or powerful. When people encounter something larger than their everyday experience, such as a mountain range, a star-filled sky, or the open ocean, the mind may respond with admiration rather than anxiety. This feeling of awe can create a sense of connection to the natural world. Sailors often describe similar emotions when travelling long distances across open water. Spending days or weeks at sea changes the way a person perceives the ocean. At first, the horizon may seem endless and unfamiliar, but over time, the rhythms of wind, waves, and weather become easier to read. Sailors learn to observe subtle changes in the environment. Cloud formations reveal approaching storms. Wind direction indicates how the ocean currents might shift. The movement of birds sometimes suggests the presence of nearby land. As knowledge grows, the ocean transforms from a mysterious expanse into a landscape filled with recognizable signals. This familiarity reduces uncertainty. Another reason some people love the deep ocean involves the sense of calm it can provide. Large bodies of water often create environments where the pace of life slows down. Watching waves roll across the surface, or listening to the steady sound of water moving against a shoreline can encourage relaxation. Psychologists studying natural environments sometimes refer to this effect as blue space therapy. Blue spaces include oceans, lakes, and rivers. Research suggests that spending time near these environments may reduce stress and improve mood for many individuals. The gentle, repetitive movement of water, combined with wide-open views, can encourage the brain to relax. For people who enjoy the ocean, the vastness of the sea does not feel threatening. Instead, it provides a sense of freedom. Standing near the shoreline or floating on the water allows the mind to escape the crowded structures of cities and daily routines. The horizon stretches outward without interruption. There are no buildings blocking the view, just water, sky, and the steady movement of waves. For some individuals, this simplicity feels refreshing. It reminds them that the world is larger than the spaces humans usually occupy. Ocean explorers often describe another powerful motivation behind their fascination with the deep sea: discovery. Even today, the ocean remains one of the least explored environments on Earth. Scientists estimate that millions of marine species may still be unknown to science. Entire underwater landscapes remain unmapped. Every expedition into the deep ocean carries the possibility of discovering something entirely new. For researchers, this sense of discovery is exciting. They may encounter unusual organisms glowing in the darkness, underwater volcanoes releasing mineral-rich water, or seafloor formations shaped by geological forces. Each discovery expands our understanding of the planet. The same unknown that may trigger fear in some people becomes a source of inspiration for others. Another factor that influences how people perceive the ocean involves personality. Some individuals naturally prefer environments that feel predictable and structured. Others are drawn toward exploration and new experiences. People who enjoy adventure often feel energized by unfamiliar settings. The deep ocean, with its vast scale and hidden ecosystems, offers exactly that kind of experience. For them, the unknown is not something to avoid, but something to investigate. It is also important to remember that human emotions rarely exist in isolation. A person can feel both awe and caution at the same time. Even experienced divers or marine researchers sometimes pause when looking into deep water, where the seabed disappears into darkness. They recognize the immense scale of the ocean and the powerful forces operating beneath its surface. But that recognition does not necessarily create fear. Instead, it encourages respect. Respect for the environment and for the challenges involved in exploring it. Over time, respect combined with knowledge allows many people to form a positive relationship with the ocean. The vastness of the sea becomes a reminder of how diverse and complex our planet truly is. For those who study marine life, sail across oceans or explore underwater environments, the deep sea represents one of the most fascinating places on Earth. It is a world where sunlight fades, pressure increases, and life evolves in remarkable ways. And while some individuals may feel uneasy when imagining its depths, others feel drawn toward the mystery. They see the ocean not as something frightening, but as a place of discovery, beauty, and endless curiosity waiting beneath the surface. For many people, the feeling associated with deep water does not arrive as a dramatic moment of panic. It is usually quieter than that. A person might simply hesitate before swimming far from shore. They might feel uneasy when looking at images of the open ocean, or when watching underwater footage where the seabed disappears into darkness. Sometimes the reaction is subtle enough that it is difficult to describe, yet these reactions reveal something interesting about how the human mind works. Thalassophobia, like many fears, is not simply about the environment itself. It is about how the brain interprets uncertainty, scale, and unfamiliar conditions. The ocean becomes a powerful example of how human perception responds when confronted with something vast and difficult to understand. To begin with, fear is one of the brain's most important survival tools. Throughout human history, fear helped our ancestors avoid dangerous situations. If early humans approached a steep cliff, a fast-moving river, or a territory where predators might hide, the brain quickly activated caution. This response encouraged people to slow down, observe their surroundings, and consider potential risks before acting. Without that system, many individuals might have wandered into dangerous situations without hesitation. Fear, in this sense, functions less like an enemy and more like a signal. It alerts the brain when the environment contains unfamiliar or unpredictable elements. The ocean, especially the deep ocean, contains many such elements. When a person floats above deep water, the brain notices several conditions at once. The bottom cannot be seen. The depth extends far beyond normal visual experience. Movement in the water may be difficult to interpret. The surrounding environment lacks familiar landmarks. All of these factors contribute to a feeling of uncertainty. The brain recognizes that it does not have enough information to fully understand the environment. When this happens, the mind becomes more cautious. Psychologists often describe this response as a protective prediction system. The brain constantly predicts what might happen next in order to prepare the body for action. When information about the environment is incomplete, the brain tends to assume that caution is the safest response. This does not mean danger is present. It simply means the brain prefers to prepare for the possibility rather than ignore it. In the case of thalassophobia, the ocean provides a perfect example of an environment where prediction becomes difficult. The surface may appear calm, yet the depth below remains invisible. Even if nothing unusual exists beneath the water, the brain recognizes that it cannot confirm what lies below. This gap between knowledge and visibility becomes the space where fear often appears. But fear also carries another function. It invites learning. When people encounter something that triggers uncertainty, curiosity sometimes follows. The mind begins asking questions. How deep is the water here? What creatures actually live in these depths? How does pressure affect life at the bottom of the ocean? What causes the strange light seen in deep-sea organisms? As these questions lead to answers, the unknown gradually becomes more familiar. Information replaces imagination. Understanding reduces uncertainty. Many individuals who once felt uneasy about deep water eventually become more comfortable as they learn about marine environments. For example, someone who studies marine biology may initially feel cautious about diving into deeper waters, but as they learn how marine ecosystems function, they begin recognizing patterns that once seemed mysterious. Fish follow predictable behaviors. Ocean currents move in ways that scientists can measure. Deep sea organisms display adaptations that make sense when viewed through the lens of evolution. Knowledge transforms the unknown into something understandable. The fear does not necessarily disappear entirely, but it changes. Instead of imagining hidden dangers everywhere, the mind begins interpreting the environment more accurately. Another important lesson that thalassophobia reveals about the mind involves imagination. Humans possess one of the most powerful imaginations among all animals. This ability allows people to create stories, invent technologies, and imagine futures that do not yet exist. But imagination also means the brain can generate vivid scenarios even when there is no evidence that those scenarios are real. Looking into deep water provides a perfect canvas for imagination. The surface may reveal nothing, yet the mind begins constructing images of what might exist below. Sometimes those images are influenced by movies, books, or stories about the ocean. Sometimes they arise simply because the brain prefers to fill empty spaces with possibilities. Understanding this process helps explain why thalassophobia can feel so intense, even in safe environments. A person watching a video of deep water from their living room may still feel uneasy. The brain recognizes the visual cues of depth and darkness, and responds as if the environment were physically present. Yet this same imaginative ability also allows humans to overcome fear. When people gradually expose themselves to unfamiliar environments in safe ways, the brain learns new patterns. A person who begins swimming in shallow water may slowly move into deeper areas as confidence grows. Divers often train step by step, learning to manage breathing, buoyancy, and underwater navigation before exploring more challenging environments. With each experience, the brain updates its predictions. What once seemed unknown becomes recognizable. What once triggered caution may eventually feel comfortable. But facing fear does not always mean eliminating it completely. Sometimes fear simply evolves into respect. Experienced sailors still respect the power of the ocean. Marine researchers recognize that deep-sea exploration requires careful preparation. Even confident swimmers remain aware that water demands attention and skill. Respect encourages responsible behavior. It reminds people to consider weather conditions, currents, and safety measures when interacting with the ocean. In that way, fear can serve as a guide rather than a barrier. It encourages preparation rather than avoidance. Another insight thalassophobia provides involves the relationship between humans and nature. Modern life often surrounds people with controlled environments. Cities contain buildings designed for stability and comfort. Artificial lighting removes the darkness of night. Technology provides constant information about the world. The ocean exists outside that controlled system. It is vast, powerful, and largely independent of human activity. Looking across the open sea reminds people that the planet contains environments far larger than any city or structure humans have built. This realization can feel intimidating at first, but it can also inspire humility. The ocean represents a reminder that humans share the Earth with ecosystems that operate on scales beyond everyday experience. Understanding this relationship can change how people view their own fears. Instead of interpreting thalassophobia as a weakness, It can be seen as a natural response to encountering something truly vast. The brain recognizes the magnitude of the environment and reacts accordingly. At the same time, humans possess the ability to learn about these environments. Through science, exploration, and careful observation, people continue expanding their understanding of the ocean. Every expedition into deep water reveals new information about marine ecosystems, geological processes, and the remarkable organisms that inhabit the depths. In this way, Thalassophobia becomes part of a larger story about curiosity and discovery. The same environment that triggers uncertainty also invites investigation. The ocean's vastness may challenge the mind, but it also encourages people to explore, study, and learn. And as knowledge grows, the deep sea becomes less of a mysterious void and more of a living world filled with patterns waiting to be understood. The fear may never disappear completely. After all, the ocean will always remain enormous, powerful, and unpredictable. But facing that fear reveals something meaningful about the human mind. It shows how curiosity can exist alongside caution, how imagination can lead to discovery, and how the unknown often becomes the starting point for understanding the world around us. And so, after drifting slowly through darkness, depth, strange creatures, and the quiet mysteries of the ocean, we arrive once again at the surface. The sea above us looks almost the same as when we began. Gentle waves rise and fall. The horizon stretches outward in a calm line where water meets sky. From this distance, nothing about the ocean seems especially unusual. It appears peaceful, predictable, almost simple. Yet now you know something different. Beneath that calm surface lies a world that extends downward for thousands of meters. A world where sunlight disappears, where pressure becomes immense, where creatures glow softly in the darkness, and landscapes remain hidden beneath layers of water. The ocean is not empty space between continents. It is the largest environment on Earth, covering more than 70% of the planet, and containing ecosystems that scientists are still discovering. And even now, with satellites orbiting the planet and machines capable of descending into the deepest trenches, much of that world remains unexplored. Entire mountain ranges lie beneath the sea. Vast plains stretch silently across the seafloor. Organisms drift through darkness that human eyes have rarely seen. When people experience thalassophobia, when they look into deep water and feel a quiet tension in the back of their mind, that feeling often comes from this realization. The ocean is enormous, and the human brain, which evolved in forests and valleys, suddenly finds itself facing a landscape that refuses to reveal its full shape. There is no bottom visible beneath the surface, no clear boundary where the environment ends, just depth fading into darkness. For some individuals, that unknown space triggers caution. The mind becomes alert, scanning for information it cannot easily find. But that same unknown space has also inspired generations of explorers. Throughout history, humans have crossed oceans in fragile ships, built machines capable of withstanding crushing pressure, and sent cameras thousands of meters below the surface simply to see what might be there. Curiosity has always travelled alongside caution, and perhaps that balance is part of what makes the ocean so fascinating. Because the sea represents one of the last places on Earth where mystery still exists on a truly enormous scale. Many parts of the ocean floor remain unmapped. Many species of marine life have not yet been identified. Even the physical processes shaping underwater ecosystems continue to reveal surprises as scientists study them more closely. In some ways, the ocean reminds us that the planet is still full of questions waiting to be answered. Standing on a beach, looking out across the water, it is easy to forget how much lies below the surface. The waves roll in predictable rhythms, and the shoreline feels familiar. But just beyond that horizon, the seafloor begins to descend into landscapes that most people will never see. And that awareness has always stirred the human imagination. Stories about sea monsters, hidden cities beneath the waves, and strange glowing creatures have appeared in cultures across the world. Long before modern science explained the biology of deep-sea animals or the geology of underwater trenches, people sensed that the ocean contained secrets. Even now, with all that science has revealed, some of that mystery remains. Perhaps that is part of why the ocean continues to capture our attention. It reminds us that not everything has been mapped or measured. Some places remain quiet, dark and distant from everyday experience. Yet despite that distance, the ocean is deeply connected to human life. Ocean currents influence global climate patterns. Marine ecosystems produce much of the oxygen we breathe. Countless species depend on the sea as their primary habitat. Even the water cycle that brings rain to forests and rivers depends on evaporation from the ocean's surface. The sea may appear distant from daily life, but in reality it plays a role in nearly every system that keeps the planet functioning. Understanding the ocean therefore becomes more than just scientific curiosity. It becomes a way of understanding the world itself. And every new discovery made in the depths helps scientists learn more about the delicate balance that supports life on Earth. For individuals who experience thalassophobia, the ocean may always carry a sense of unease. Looking into deep water may continue to produce that familiar feeling of uncertainty, but perhaps that feeling can be understood in a different way. Not simply as fear, but as recognition. Recognition that the ocean is vast. Recognition that the human mind encounters something larger than its everyday experience. Recognition that the unknown still exists in a world where many mysteries have already been solved. In that sense, thalassophobia reveals something meaningful about human nature. We are creatures that seek knowledge, but we are also creatures shaped by caution. We explore the unknown carefully, step by step, learning as we go. And the ocean remains one of the greatest unknowns our planet has to offer. Somewhere beneath the waves tonight, deep sea creatures drift through darkness illuminated only by their own faint glow. Silent currents move across underwater plains. The deepest trenches remain cold and quiet, untouched by sunlight. Above them, ships cross the surface without realizing how far the water stretches beneath their hulls. And here you are, perhaps listening in the quiet hours of the evening, a little farther along your own timeline than when this journey began. Maybe you're near the ocean tonight. Maybe you are thousands of kilometers from the nearest shore. Either way, the same vast sea continues moving quietly across the planet, connecting distant coastlines and hidden depths in ways most people never see. Before we finish, let me gently ask again the question from the beginning. Where are you listening from right now? And what time is it in your corner of the world? Perhaps the ocean is far away, or perhaps it is only a short walk from where you are. Either way, it is still there, stretching across the planet in quiet rhythms, carrying its secrets beneath the waves. If you found this journey calming, interesting, or simply a pleasant way to unwind before sleep, I would be very grateful if you gave the video a like and maybe subscribe to Life Beyond Seen. It helps this quiet space of curiosity reach others who might enjoy drifting through science and mystery at the end of the day. For now, though, there is nothing more you need to think about. Just the quiet thought of the ocean moving somewhere out there in the darkness, waves rising and falling as they have for millions of years. Sleep well, fellow traveller, wherever you are and whatever time it is in your small corner of this vast ocean-covered world.